Hello everybody, welcome back to Classic Arcade Repairs. This is Sean with you. And today I am going to be starting a Robby Roto Midway card rack system board set repair. And since this is going to be a pretty involved process with all of the maintenance that goes into the cage and everything, I'm going to be splitting this one up into like a series. I'm not gonna, because it's just easier for me to do it that way with this kind of a repair where there's so much conditioning that has to be done to the board set. So this is part one, Robby Roto. And what part one is basically going to consist of is I'm going to take you through how I will build the harness for this. Now I've already got the power because I just finished a space zap. So I've got the power done. But I have to do the pinout to interface to my setup. So that's what we're going to do. And Robby Roto is a color game, but since I don't have the RGB interface PCB, we're going to look at it on the black and white monitor, just like we did Space Zap. So that is the plan, Stan. Yeah, so first thing to do is look at these things I got printed off. And these are our pinouts. So here we have, these are on the game PCB. You have a 24 position that's got your right left magic button. I'm going to play Robby Roto on MAME. You know, that's what we should do, is we should set this camera up. I'm going to play it on MAME because I am not familiar with this game. And, yeah, we got audio. We're just going to use audio 1 and ground. So that's the 11 position. You know, pin 4 is going to be our audio, and ground looks like it'll be pin 11. Audio return actually 6. So we'll go 4 and 6. That'll be our audio. And we'll do a coin and where's our start? Select one player. Okay, that's all coin and one player's all on that guy. This is where our video comes off, which is J3 on the game PCB. J3 video right here. Video is pin 11. And those are the component. These are the signals that go to the RGB interface. These 3 signals. All we care about is this video signal. And of course ground. So video signal is 11 on J3. So we're going to have 11 and our ground will be 12 right next to each other. So our ground will be 12. Video signal is 11. That'll go to our black and white monitor. So I'm going to determine the length of these wires, and I'm going to make them longer than I did for Space Zap because I thought they were long enough, and they are really, but I want more slack. So I'm going to make these probably from here, the end of this table, I'll probably go to about right the end of this. I'll do the length of this mat, the length of the blue mat for the wiring. That's going to be a lot of wire, but we got our box of junk wire over here. You guys are not going to believe what I found in that junk wire when I was wiring up Space Zap. I'm going to show you what I found. And this stuff came from, I believe, from my friend Todd. Gave me this box of just wire. Remember, this is going to be my berserk, right? I'm going to make a berserk out of this. And I cannot believe I found this. In that junk was this harness. And this harness is berserk. Are you kidding me? So I took that and I separated it out and I put it in here. It's hacked up a little bit. You know, it's got some hackage on it, but that's okay. That's a nearly complete harness, it looks like. I mean, score, you know. Yeah, so, okay. So I'm going to start picking some wire. I'm going to go through here and I'm going to count every wire that I need. I'm going to give it a color and go from there. Okay, I have J1 right here. That is this guy, J1. And then J2 and 3, I'm just going to use one big thing here to span the whole thing, J2 and J3, because I do have wires on both J2 and J3. So 2 connectors for this guy. Robby Roto. And here is the board set. I just popped this up so that we can look at that. And yeah. Okay. So we'll go ahead and I'm going to start grabbing some wire and kind of mapping it to this. So let's do it. Guys, look at what I just pulled out of the box. I just put this box over here, starting to go through wire, and I pulled this out of the box. This is Berserk. It is an absolutely complete, unhacked PCB interconnect harness for Berserk. Unbelievable. What a score. I've got the board set for Berserk. I've got a harness now for Berserk. I got a cabinet for Berserk. I've got the monitor. I've got everything for this. I need to get a marquee and a control panel. Marquee and control panel, and I'm in. And that'll be another series to go through. And then we've got the Star Trek. I want to put that back together. The monitor and stuff's right there. Yeah. Future plans. All right, just wanted to point that out really quick. What a score. Unbelievable. All right. Thank you, Todd. Because I know this box came from Todd. I'm sure it did. I don't know where else I would have got it. So, all right. Awesome. Okay, so I have mapped out my colors. This is my audio, which is a twisted pair. Which is right here, twisted pair, white and brown. That's audio. And then video, I'm using white for the video signal and the green and black right here, for that will be my ground. There's the video right there. White, green and black. Okay, and then over here, one player coin switch is just a short wire that you ground to the cage to coin it up. So that's not actually going to my interface. So that's just like a partial wire. But for the test, I'm going to wire test up, and that's going to be orange and white. I'm going to, of course, up. Up is always kind of brown. I always do down as orange. And left is going to be yellow today. Right is going to be red and blue, red with blue. And the magic button is going to be red with green. And of course, one player start is just a partial wire. So whatever scrap I have laying around is just, that's a partial wire that you just ground to the case, the cage. So yeah. Now we've got our wires mapped out. We'll go ahead and start stripping one end and crimping on the little Molex pins to go into the Molex connector. That's it. Let's get to it. Okie dokie. Just kind of let the camera go for a little bit. I know you guys love my crimper. I know you love it. Okay. We'll just start picking wires and doing them. My glasses. I had to go get me a cup of coffee for this. My Coke bottle glasses. and my wonderful crimper. Oops. It's wonderful. Isn't that lovely? I'm going to check this out really quick. Yeah, you got a good view of everything going on. Nice wide pan. You know what? Maybe I can zoom her in just a little bit. Yeah, just make sure I keep working right about where the center of the paper is. Yeah, we'll go with that. Let it run for a little bit. Kinda. Okay, yellow. What did I say yellow was? That is going to be J1. And this goes on the board set like that. And this is 1, this is 24. So yellow is 11. So let's count to 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Boom. Okay. Yellow's done. Now let's just grab them. This is orange and white. Orange with white. Okay, orange with white is the test switch, which is J24 or J1, pin 20. Pin 20 of the same guy. So if this is 11, that's going to be 12, 13, 14, 15, 16, 17, 18, 19, 20. And then it's 1, 2, 3, 4. So we know that's right. 4 to the end. Okay. Let's grab this guy. This is red with blue. Come on. Huh. I've got this thing set really loose as to not tear wires off of it. So sometimes it just doesn't want to grab a wire or grab the insulation, which I'd rather that than pull wires out. We don't need that. We need all those wires that we can get. Okay, this is red with blue, which is number 12 of this guy. Numero 12. So that's going to be right here. Okay. Now let's go brown. Beautiful. Okay. Brown is 9. Pin number 9. So if this one was 11, then that's 10, this is 9. Bingo. Let's do red with green. This is the fun part of arcade board repair services. Building harnesses for new repairs. And unfortunately, okay, this is number 14. Unfortunately, every one of these card rack systems has a different pinout. 11, 12, 13, 14. Every one of these card rack system games has a different pinout. So you got to make a different loom basically for each one. I could do it all on one, but it would be such a cluster with wires soldered to the same spot and stuff. I'd rather just do, each of them have their own harness. We're going orange now. And that is number 10. That's right next to brown. What can brown do for you? That's up, down, left, right, fire, and test. Test. Up, down, left, right, fire. This guy's done. So we can twist this all up. This one is not going to get any more wires. So I'm going to twist this up. And then I'm going to start wire tying it. See, I just kind of twist it, you know. And let me grab my wire ties. I don't really need these big ones. I'll grab some of the smaller ones. Okay. Put another one right here. And twist them up a little bit more and put one right here. And twist them up a little bit more. And let's do one more tie right here. Sweet. So that one is done. Done. J1. Okay. All right. Set this guy aside, and we're going to move on to J2. Set this guy aside as well. That one's done. J3. Let's do J2 first. I want to do this one. Oh, this is just the audio. That's easy. Okay. Let's go ahead and do. Okay. And crimp and double crimp and insulation crimp. And let's do this side. This is audio and audio ground. Get that guy out of the way. And crimp and double crimp and insulation crimp. Okay. All right. And those are J2, which is this side of this thing. And it's an 11 position. But we want 4. So we want 1, 2, 3, 4, and 6. 6 is round. There's our audio. Okay. And now we'll do our video. Okay. 1 crimp to crimp. And okay, this is our video signal, which is J3 part of this guy, and it is 11. And it looks like it's a 12 position. So it's going to be all the way to the end. I'm going to check out, pull the board out here. Oh, grab this board. Okay, yeah. Yep, we have an 11 position and then a 12 position. So number 11 number 11 will be video number 11. So that is the almost end. And then number 12, the very end, is going to be the ground. My wonderful crimper. Okay, that guy goes to the very end. There. Now we want to twist. I want to twist the green and the white video together. I want those twisted up. Pretty good. Okay, and then I want these to all be tied together, and we'll go yellow this time. Okay, let me grab 1, 2, 3 more yellow things, and we're going to kind of twist these together a little bit. Okay, and then we'll put another yellow right here. Put us another yellow right here. And we'll put us another yellow right here. Another yeller. Okay. Now we have our interfaces pinned and good to go. So now we need to do is get a fingerboard and solder these wires onto the fingerboard to go into to interface with my setup. So let me get that all ready to go and be right back, guys. Okay guys, now how this works is I have painstakingly taken the time to label everything on my connector here. Now the power is what it was with the JAMA. Then I've got 10.3, all these voltages coming off of my AR. 10.3 unregulated, negative 22. We got audio 1 and audio 2 is on the opposite side. That's going to the AR. That's Atari board's audio. And if it's just needs to go to a speaker and not be amplified, then you got the speaker there. You got negative 5. Here's my video connections. Red, blue, ground. Sync and green are on the other side. And you got test. That goes to this test switch. And then I've got various different sync signals. I got a negative horizontal sync signal there that goes to this guy, and I plug in. See, I've got the black and white guy plugged in right now. So you got black wire going to ground, and then black and white video is that white wire going out, and that goes to my black and white monitor. I just stick these over here to keep them out of the way for now. When I'm doing a color game, these go over here, red, green, blue, ground. But when I'm doing black and white, I just unplug them, I plug them in over here, and then I plug that in there, just so that they're not dangling. Okay, and then you've got your grounds over here. Positive horizontal sync. There's my black and white video. XYZ ground for vector. And I got Z, the Z input, the Y input, and the X input there. I've got 36 volts AC out. There's a vertical sync signal, negative vertical sync signal. Those all go to this. If there's a board that uses that sync, I can wire it to here, and then I can send it from here to my monitor. And on the back side we have more, this is the solder side. We've got another 10.3. There's positive 22. The other side had negative 22. There's the other audio and the other speaker. There's your video green and your negative composite. You got positive composite. I got a 5 volt DC out, I believe. The other half of the 36 volt AC. And then this goes to my Atari joystick, which is peeling off. But it's up, down, left, right, button, paddle A, paddle B. I put that there. I never use it. But why not? I put it there anyway. I wired it to this. That goes to this, and then that goes to my Atari joystick. So that's how that works. So then I have this, where I just solder these wires from this to that, plug it into there, and then I'm good to go. So I'll take you through that. Okay, it looks like we're about right here, yeah. So I'm going to try to work right here. So we'll move this guy here and flip it over, because this is the first positive side. Got to turn the iron on and get my solder and stuff, and actually turn my iron off, because I like to use a different tip for this. This guy right here, this big chisel. Let's fire that up. Okay, the big chisel. Get my helping hands to hold wires when I tin them. Get that out of the way for now, though. Get my glasses on. Okay, I'm going to go through and tin everything that I already know I'm going to use. Okay, I'm going to use ground, of course. Okay, and then black and white video, which is 25. Okay, that's that. Audio is 9. 1, 2, 3, 4, 5, 6, 7, 8. Yes. No, I am not sending this to audio. That's something that I'll show you what I'm doing with the audio. I'm not doing that. I'm sending that to my computer speaker amplifier. So that test is 16, so we'll tin test. And then flip this thing over, and we're going to do number 20, which is up. 21 is down. Left. Right. button. And then to get this thing grounded, all I have to do is short this guy. This is my ground for the joystick. All I have to do is short it to this ground. So we'll just pile in solder here and short that out. Just like that. And now it's solid. So we'll set this guy aside and we'll start stripping, tinning, putting these where they go. Okay. Yellow is, grab my sheet over here. Yellow was left. So left is up, down, left. Up, down, left. That guy right there. This is fire, I remember. The button. Yes, red and green is button, which is this input. Okay. And solid orange is down. Okay, up, down, solid orange is down, which is right here. Okay, and then brown is up. All of this, all of the prep work that goes into repairing a board. It's crazy, ain't it? This is right. But from here on out, I get a Robby Roto board set to repair. I'll never have to mess with making a harness for it. I've got a bin full of harness adapters, and this one was test, which is 16 on the opposite side. That goes here. Okay. All right. Good. And now all I'm doing to this is video. I'm going to kind of twist these together a bit so that they stay nice and together. And we're going to do video, which is white. Okay. That goes right here. And green is ground. Video ground. Video return. Okay. Done. Now this audio is different because what I need to do is solder a 2-pin thing on here because my amplifier will plug into those. So what I'm going to do, and I'll show you, is strip these and tin them. Okay, and I want to trim these back. They don't need to be that long. So let's just give that a clip, and then give this a clip. And let me grab a header. We'll be back. We'll solder that on there, and I'll show you exactly how that works. Okay, and there is my 2-pin header that is going to go onto this audio. These audio wires, and we'll go ahead and tin these. Okay, put some heat shrink down my wires. Okay, and then just solder these to this. Without, you don't want to be messing with, you want it to be good. Okay, there we go. And we're going to slide our heat shrink up. Okay. Okay. And that is that. So there's our little audio plug in it. You gotta let it settle down. It's hot. So that's that. We got every connection that we're going to use on that. So there is our Robby Roto harness, and of course I make a little tag, put on there, Robby Roto. I'm going to finish zip tying this thing up a little bit, making it nice and neat, and we'll hook it up. Okay guys, and here is the hodgepodge of everything that you need to fire up a Robby Roto. In black and white, mind you. I do not have the RGB interface, so we're doing this in black and white. But in order to get sound, because sound is not amplified on board, what I have here is, this is out of a computer speaker set, which I have adapted to my needs. You see here, this is my input. And I did this because that is perfect for Nintendo, right? To plug into a Donkey Kong, the little pins. That's why I soldered this onto my the audio. I can plug in and send this to my amplifier through this. I've had this speaker amplifier thing right here since 2002, when I built my first main machine. This is what I used for sound, because I had a real speaker, a real arcade speaker, and I ran it through this up to the speaker. This goes to the, this is the interface to the speaker itself right here, you know. But yeah, then I got the power supply here. So that is how I'm amplifying sound. This is a reset circuit that I made. All this does is on my switching power supply that I'm going to power this board with, I have 5 volts and ground tapped off of it right here. That plugs into right here, and that powers this little circuit. All it is an inverter with a capacitor and a resistor. And all it does is it charges a capacitor. This will start off when it first turns on. This will turn on. It'll be low, and it takes a split second to charge this capacitor, and then it goes high. So I can either tap the high for a Z80, or I can do the inverted off of this for an 8080. Right? You switch on. It starts low immediately. The capacitor charges and it sends a high to here. So it starts off low and then goes high once this charges. Well, if you want the inverted signal, then you just tap off of the inverted output. So it'll start high and then go low once this charges. If you know what I mean. Pin 1, when you first fire this thing up, this inverter, pin 1 will be low until this charges. And then pin 1 goes high. So that's your reset signal for a Z80. Starts low and then goes high. Well, if you want to run an 8080, then you run off of pin 2, which starts high because pin 1 is low, right? When this charges, pin 1 goes high, pin 2 goes low. So that's your signal. That's your reset signal for the 8080. That's all it is. It's a little simple circuit. It's a reset circuit. So you've got your reset circuit, you've got your speaker amplifier, I've got my power. This plugs into my switching power supply. The reset right here, reset signal, plugs into this. This is the reset that goes to the card cage. And then this is what I just built. The Robby Roto adapter to my interface. See, it plugs in here. You got the orange wire, that is test. That's the test signal. And then you've got black and white video and ground. And on the other side you got up, down, left, right, and fire. So we're ready to set the card cage up here, hook everything up and fire it up and see if it does anything at all. Okay, and this is what it looks like all hooked up. We got J1 to J1, J2 and 3, this is the other one. So those are hooked up. That runs to here. We have our audio. Remember, this is the audio out going to my amplifier, which is setting over here. And that is plugged in. I need to plug in this is the switching power supply. I turn it on with this switch. That turns the audio amp and the power on at the same time. The audio amp sits up here and it's plugged in to my speaker interface here. Yep. So this is our power input, and our reset circuit is plugged in, and you got to make sure that you plug this in the right way. You got the green as ground and then black as ground, so it's good to go. So we're ready to fire this thing up. I've already got the monitor plugged in, so I will go ahead and switch it on, and I'm going to listen to the power supply, and if I hear it tick 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 tick, you got to turn it right off. So I'll keep my ears open for that, and I'm going to go ahead and switch it on. Okay, it's doing a little reset action. Yeah, it's just resetting. So awesome. I mean, that's better than it. I mean, it's not good. Let's not kid ourselves. It's not great, but all right. I'm going to go ahead one turn, one try, just try to cycle the power. No, it's just resetting. Okay. Alright guys, well, that was a pretty involved video. I'm going to call this one part 1. And then we'll move right into part 2. Part 2, I think, is going to be reconditioning the cage. So that's what we'll do. Part 2 will be cage reconditioning, and then part 3 will probably be PCB reconditioning. So we'll see ya. I will see you for that. Okay, so we are going to disassemble this guy. Remove the boards and everything and disassemble. So let's go ahead and just pop all the boards out of here. I want to take a look at this memory board. 244s and 245s along the bottom. There's a 82S153 prom chip. And some ROMs and RAMs. Okay. Pretty basic, pretty simple. And here's our game PCB. It's got the 2 I/O chips on it. And bullet caps. Pretty basic. It's our pattern generator. Boy, this thing's got corrosion on the inside of it. I'll give you a look at that. Here's our pattern generator board. Pattern board, I guess. It's not a generator. And here's the CPU board, which has a heat sink on that chip. Nice ceramic Z80. And a bullet cap, of course. CPU board. And the RAM cards. 4027 RAM. And 4027 RAM. Okay. Dirty. This thing is dirty. I'm going to grab the camera off of the stand and kind of show you what we're looking at here. Come on. Gosh. Okay, look inside here. Look at that green. Look at that green crap. That's corrosion. And that was seeping into the board. That was the first board had that crap on it. See that? Green nonsense. This thing's going to have to take a bath in some toilet cleaner. As well as the board that was in that slot. The memory board. Look at the memory board. The corrosion along that memory board. It is not good. So this board right here is going to take a good bath in some toilet bowl cleaner. I'll remove the ROMs and the RAMs. I'll remove everything socketed. And this thing's going to take a good hydrochloric acid bath. That's a yeah, that's a base, I believe. So it needs to be an acid to neutralize it and clean it. All right. Yeah. So we got some work to do on this cage and the, oops. We are nice and filthy down in here for sure. So we'll take this apart, clean it all up, make it nice and pretty, get rid of the green nonsense, clean that board up. First thing I have to do is I have to go to the dollar store. I have to get Simple Green. I'm out of Simple Green, so I might as well buy a gallon of that, and I need to buy toilet bowl cleaner. So I'll do that and I'll see you in a while. I'm going to take these off while I'm at it. These two brackets are going to come off, so they have easier access to this thing. So, all right, I'll be back. Got to run to the store. I will be back. All right, I just got back from the store and I picked up stuff that every arcade guy needs. I always say Simple Green, but what I really mean is Mean Green. And not only did I get the spray bottle, oh no, absolutely not enough. I got the gallon. 91%. I've got all kinds of 70%, but 70% sucks. This stuff is where it's at. They had it in stock. I bought 5 little bottles. Toilet bowl cleaner for the nastiest corrosion that you'll find. You need this. And I got mustard. We got us some MAME pulled up. Checking out some Robby Roto. I just played my first game ever of Robby Roto, and I think it's pretty cool. So for you guys, for those of you who don't know this game and never seen it maybe, let's take a look at what we're dealing with here. This is what we're working on. I'm going to go ahead and coin up and play. And of course, they had to put spiders in it, you know. Spiders are the bad guys, of course. You guys know I love spiders. Gotta turn it up a little bit. I guess that's the magic, is you can turn into a Pac-Man look-alike character. Oh, I forgot one of the guys. Look at the little devil guy. This is definitely better than Space Zap. Definitely better. Oh. Yeah. So that is Robby Roto. That's pretty cool. I kind of like it. It's definitely better than Space Zap. Yeah, so now you know. Okay. Robby Roto. You know what I'm going to do? Robby Roto is the same exact board set as Space Zap, which I just fixed, other than the Space Zap doesn't have a memory card. This is the Space Zap game PCB. It's got the ROMs on it and everything. So what I'm going to do is I'm going to just see if the Robby Roto memory board, which is right here, and that's the flaky one. Nope, I am not putting that in this cage. Scratch that idea. Let's put this back together. I'm not doing it. I'm not putting that corroded board in here. Scratch that idea. Actually, that one goes right here. Space Zap is good to go. You know what I could do is I could test his RAM cards. I can do all that later. I'm getting off track. I've removed the 2 brackets for that. Set them right there out of the way. I got my toilet bowl cleaner. I got my tea. My herbal tea. And we'll remove this board from the cage. Okay. Here. And these 2. Okay. And let's put this back. Put this back together. Come on. Come on, Robby Roto. Actually, I should leave this off because I'm seeing some greenness down here, and I want that all to get exposed. I'm going to remove this tag. Remove the tag. Okay. Yeah. Here's our ground plane board. It's nasty. I'll have to carefully inspect the pins inside of it after I clean it. But this is going into a mop bucket with hot, a mixture of hot water and toilet bowl cleaner. Yeah. So let's do that. Let me get that all prepped. Okay, looky there, it's actually a good fit. The mop bucket. So I'm gonna douse this thing with the toilet bowl cleaner, scrub it with a toothbrush a little bit, and then I'm gonna fill it with some hot water. I think. First thing I'm gonna do is I'm gonna let it soak in toilet bowl cleaner. I'm just gonna squirt it, and I might be able to do that right now. Put these in there while we're at it. And look at that foam up. See that foaming? Just foams when it hits it, that acid. Good dousing. Okay. Next is going to be a little toothbrush action. Be right back. Okay. Let's see what. How about right there? Just toothbrush. Little toothbrush action. Brush away the grossness. Okay. And how's that? Yeah, it's not bad. Okay. IG. Okay. I will not waste this toilet bowl cleaner. I'm going to use that on. I got to take this outside. That stinks. I'll be right back. Okie dokie. Now, to address this board, first thing I'm going to do is I'm going to take a picture of it. Because well, I think the first thing I need to do is identify the ROMs. They do have, okay. Yeah, I'm going to have to just identify them. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, and these are all 61/16s. Now I'm going to take a picture, because a picture is worth 1,000 words, guys. Alright, so let's go one right here. I want a picture of all of these driver buffers. Let me look at that picture. Yep, I can zoom in and see what's what in what position, because you have a 245, 244, 244, 244. So there's only one 245, and it's right here. I'm going to go ahead and take another picture, though, of this side. Right like that. That way I can scan over here. I can see everything. That way I can see everything. I know what everything is, where everything goes. And now, these are 2532 EEPROMs. You know, I can put the fluke on this thing and that'd be kind of cool to do. Rams. Okay, 245. Oh yeah, we got these two guys too. And it looks like on, off, on, off, on, off, off, on. On, off, on, off, on, off, off, on. They're the same, but I need to take a picture of the orientation of these two guys. Okay. Okay. There we go. We're going to remove these. They're the exact same thing. Those two chips are the same chips. Okay. Okay. And that's that. This board is now stripped. This thing had a battery on it. That is what leaked all over the place. This thing had a battery on it. Goodness gracious. Yeah. Okay. That's what it was. Goodness, I guess it could be worse. Okay. This socket is no good. The inside is completely gone. That is weird. I'll show you. Let me grab the camera. I will show you what I'm talking about. It's this guy right here. I'm going to kind of pick this up a little bit. Zoom in. It's the ground pin here. See the one right next to it? You can see the metal. Come on. And then you see the ground, how it's missing? It's broke right out of there. Or it's pushed down and crushed. Either way, it's no good. Wow. Okay. Alrighty. Well, we'll be back. This board needs some TLC for sure. Alright guys, I'll be back. Okay, and I popped that socket top off. And check it out. There's the ground leg. See how it's broke off? Yeah, sorry. I'm trying to see it right there. That's that pin, that's broke. That is a ground failure on that RAM, so no wonder that ain't gonna work. I'm gonna have to look at all of these sockets. This one right here looks like crap. I mean, it just looks like crap, right? Dirty, nasty. I don't have much faith in these sockets. As a matter of fact, they're going to have to all be replaced. Wow. Yeah. Not good. Okay. We'll get it. Here's more greatness. See, the socket right here has completely fallen apart. I'm just pulling the tops off of these sockets. See all those broken pins broken on that one? And then over here, look at that, all those broken pins. Yeah, nice. Alright, I'm going to remove these three guys and we'll have this board stripped, and then it's got to go into a toilet bowl cleaner bath. Okay, I'm just showing you doing one of these. I've done all of them, cleaning them. I got this wire sanding wheel, and I'm doing the edges, the contacting edges. Just kind of buzzing them. Just like that. Just like that. I went ahead and did all of them like that. And I'll show you that ROM PCB. It was a mess. Well, the reason I'm doing that is because, you know, they were in contact with that thing that was all corroded out. So I'm just cleaning them all up. Okay, and this is that ROM PCB. I really had to clean the edges and clean that, and it kind of took some of the material right off here. It was so bad, but I just had to go around the whole side of it and really get all of that junk off of it. It went around this side too. Just got all of that. That was the negative side of that battery, and just got all of that junk off of there and all the way around. So, and after I did that, I gave it another little vinegar bath once I dusted off all of that junk. So this one hopefully is good to go now. I'll have to replace everything, of course, but I have to clean these up. Okay. And by the way, here is the cage now. All the green corrosion junk is gone. And it's nice and clean. This one was the worst. The last one. Some of those some of these little tines right here, you can see some of them are broke right off. They just corroded right off, which is, that's fine. I'd rather them not be there. But all of the corrosion is history, which is awesome. Nice and clean. So next thing is simple green, hot water, and this guy have a date. Okay, I got my brand new bottle of simple green. Let's get at it. I'm going to spray first. Spray down in that channel, those channels good. Okay, now I'm going to let this set. Actually, let me grab my handy dandy cleaning toothbrush and kind of go to town with this thing a little bit. Put this thing up here like this. Get down in there good. Okay. Dirt on the bottom too. Don't need that. Because we are going to be reflowing this, remember, so better to get it clean while we got the chance. Lots of dirt. Okay guys, this is going inside to the bathtub now. Hot water, rinse, and then alcohol. Well, hot water, rinse, and I'm going to blow it dry. Then I'm going to clean inside the channels with Tarnex. Be right back. Okay, the back plane PCB. I just got done cleaning it and drying it, and if you look in here, I don't know if you'll be able to see. You see the green tabs? Can you see them? Green. Green. This one's fine. This one is fine. The ones back towards the back will be fine, because remember, the corrosion was up front. These two guys are getting replaced right here. And then on the back of this, I'm going to take that wire wheel that I used on the other ones, and I'm going to clean all around this board. And then this thing, I'm going to remove these two guys, and then I'm going to give this a nice bath in vinegar. Scrub it with a toothbrush and some vinegar all over the thing. If you don't nip this in the bud, this corrosion crap, you got to nip it in the bud. Otherwise, 10 years from now, this thing will be totally corroded again. So, we are taking care of it. Okay, guys. Playing destruction a little bit. I tried desoldering this from the back, and there was just no doing it. So this is going to be a very painstaking process. We're having to break these two off, and I'm going to have to do the old pick and pull thing. I'm taking this and I'm just kind of breaking these. I'll keep these little keys. I can put those in the new ones. These two are the two that I'm going to replace. And you can see this one is not nearly as bad as this guy. I'll bring the camera down and in so that you can see just how bad the corrosion is. It's terrible. But this is going to be a very painstaking process of removing these things. See, this one's not as bad. So I'm going to replace these two lines, and then I am going to wash this in toilet bowl cleaner really good once it's all done. And I still have to sand around the edges. See the green nonsense over here? I still have to clear all of that off. Clean this thing in toilet bowl cleaner and scrub it. Get toilet bowl cleaner down in these channels really good so that I want to wash away any little green that might be down in there. So, all right. Well, guys, I am sadly going to throw in the towel on this back plane. These things are just too far gone, and you cannot desolder them. It's just kind of destroying the thing trying to take it apart. It's just not doable. Sometimes the corrosion just eats stuff away and kills it. And this has been killed. So I'm going to stop with this. He's just going to have to use a different cage. I'll repair the boards, and I'll use the Space Zap cage to test the boards. But this thing right here is no good. It's just dead. So unfortunately, that's just sometimes you can't repair stuff. And this one is so corroded that I can't even remove these without it looking like that. The solder will not flow. it'll barely heat up enough to release the pins. So yeah. Well, we'll move on with the board repair itself, and you know, I've got the space zap cage. We can use that to test the boards. But this one, unfortunately, the battery has claimed it. The battery leakage has claimed this board. Okay, in the ROM PCB, the memory board is stripped. And I've kind of gone over, and anything that looked like alkaline corrosion got sanded off again. Just going through and vigilantly looking for any kind of corrosion. And I am going to give this another soak in vinegar. I'm not using toilet bowl cleaner. I don't need nothing that potent at this point. I'm just going to use some vinegar. Give it a nice little bath with, toothbrush it, scrub it around. This thing shouldn't corrode anymore after that. So, all right, I'll do that. And here's all the junk, by the way. All the pins that came out. Yeah. And we'll go ahead and fix this guy up, repopulate it and everything. So I'll do that. I'm gonna clean the contacts down here too while I'm at it. Be right back. Okay guys, I am going to use the space zap cage to repair this Robby Roto set, but I have informed the owner of this that this is available right here. This is a Repro Bally card cage motherboard. There is the answer to his problem right there. It's not exactly cheap, but it's probably, I mean, I'm going to say it's worth every penny of that. So that's the web site. Pause if you need. But for all of your flaky Gorf needs, Wizard of War, whatever, this is available. Okay, the ROM, or the memory PCB, is back together. All new sockets. I had to replace one RAM using my new Inquisitor. This one was bad. And then I used my chip tester, that guy, for these chips that were here. And two of them were bad. One of the 245s and one of the 244s came up bad. So yeah, so we got all new sockets everywhere. All the sockets are new. I am going to dump these and verify them with ROM ident to make sure that the files are good in here. And the only kind of glaring issue that could be with this board now is this row of chips. I think these are fine. I think these will be okay. They weren't really subject to nastiness, but this row right here kind of was a little bit, not terrible, but somewhat. So anyway, next thing I'm going to do is test these out, make sure they're good. Be right back. And here is the board set all cleaned up. It's your CPU board. The memory board, which I have yet to verify the ROMs. I'm getting ready to do that. Just wanted to take a little shot of all of the boards. the pattern board, and the game PCB. Before I even consider firing this thing up, all of these bullet capacitors will be replaced on all of the boards. RAM card number 1 and RAM card number 2. There you go. So now I'm going to go ahead and get my programmer out, and we're going to dump these guys and make sure they're good. Okay, we'll go through doing a couple of these. I got my Andromeda Research AR Labs. What is it? The AR-32A programmer. This is my honest opinion, this is the best programmer for EEPROMs that you're going to find. I had one of these. I bought it years ago. I bought it probably 12 years ago, 13 years ago. And a couple years, I don't know, 5 years ago maybe, I bought a Data IO 29B, and then I sold my AR Labs programmer because I was like, I don't need 2 programmers. Well, I missed this one for EEPROMs so much that I just recently, within the last couple of months, I bought another one. And they're not cheap. They're like $300. $350, I think, is what I paid because I bought the 2532 adapter. So, yeah, it's not cheap, but it's just my favorite one. It's my favorite for EEPROMs. I'll still use my 29B for oddball stuff and prom chips and stuff like that, bipolar ROMs. But yeah, this thing's the bomb as far as EEPROMs go. So we're gonna set this thing up. We're gonna be dumping 2532s. So go over to 2532s, hit insert. It tells you your dip switches, and it requires the adapter. So the dip switches are set, so we're good to go. And just verify these are 2532. So we'll go ahead and put it in there, and I'm just gonna dump them first. But first I'm gonna change the path. You have to do this every time. I'm gonna make ROMs my path. Insert that path. Good to go. Save device to disk file. That's what I'm gonna do. So B. And I'm gonna call this one 3 dot bin. 3 dot bin. And is it in the socket? Yes, it is. Now it's dumping it. Okay, done, complete. So 3 is dumped. Now here's 2. And that pin is bent. Okay. B. C.ROMs is our path. That's good. We're going to call this one 2.bin. And it is in, yes, and it is dumped. How easy and simple this is. And one of our legs is messed up. Okay. B. B. 10.bin. And go. Done. This one is 6. Damn these legs. Okay. 6.bin. Okay. Check the legs out. Okay, 7 dot bin. Done. And this one is 8. Okay. This one is 4. Okay. So simple. This one is 9. And here we have 1. Okay. And 5. Okay, they're all dumped. So now we're going to exit, which is 0. Exit program, yes. Okay, now we're going to, I don't have internet out here. I don't have internet, guys. Not Wi-Fi. So I need to find, what did I do with, there it is. I'm going to transport, I'm going to put these files on this guy right here, and I'm going to transport them over to my computer over there, my desktop, because I have internet connected to that, and then I can ROM ident these. So we'll go to the ROM file, and I'm going to make a, oops, no, I didn't want that. I want to make a new folder. Come on. Oh my goodness. New folder. We're going to call it Roto. And all of these dot bins got to go in there. 1 dot bin, 2 dot bin, 3 dot bin, 4, 6, 7, 8, 9, 10. And I'm going to delete all of this stuff because I don't know. I usually always keep this folder clear. Okay, now this Roto is going to get sent to Arcade ROMs. Okay, done. I'll go ahead and turn this guy off. And then I'll meet you. Well, I'm going to take care of this. I'm going to view these on the other computer, make sure they're all good. If they're not, I'm going to go ahead and program them, and I'll let you know if any were bad. And then we'll be back. Okay, all of the ROMs dumped and tested great. Tested fine. They're all Robby Roto ROMs. Now I'm just kind of cleaning them up. I've already cleaned 6 of them. I'll show you how I do this. I got this fiberglass pen guy. These aren't terrible, so I'm not using any kind of Dremel or anything like that. And I know my hand's going to be right in the way. You won't be able to see. But I just kind of knocks off. It cleans them up really good. And then I'd take and do this. I don't know if you can see how nasty that is? I hope you can see that. Well, that just kind of cleans them up. That's good enough. And then I do the opposite sides of these, just clean them up. And do another one here. Try to keep my hand out of the way so you can see. And then underneath. And so I got two more to do, and then we'll be putting these back in the board. And here is our memory board all put back together. That chip is new. That's new. That's new. And everything else is replaced, all the sockets and everything. These guys are the right way. Okay, that's it. So I'm going to take Space Zap there, that cage, and I'm going to use that cage to test this board set. First thing I'm going to do is I'm going to take the RAM cards. I'm going to hook Space Zap up because I know Space Zap works, so I'm going to make it easy on myself. And I'm going to test the two RAM cards and the pattern board in that with Space Zap. Yep, that'll tell me if those boards are good. Okay, here's Space Zap back at it. And yes, this customer is both of these board sets, so luckily I've got this one here to work on his Robby Roto as well. But my preliminary testing is this pattern board is for Robby Roto, so it is good. Both of the RAM cards are bad, which totally sucks. Yeah, these RAM cards are both the Space Zap RAM cards, and both of these guys are bad. So, yeah. I guess the next thing I can do is test the CPU board. And what I'll do is I'll just pop this one up and then put the other one right here. I'll pop this one up out of here, and then I'll put the other one down in there. So let me do that. Okay, right now I have this thing running with the original Space Zap CPU board. Now what I'm going to do is I'm going to shut it off. See, right here is the Robby Roto CPU board. So what I'm going to do is shut this thing off. Okay, I'm going to pop up the CPU board for Space Zap, and I'm going to put down this one. Now it's in, and we'll fire it up. And you'll see this CPU board has an issue. There's something not right with it. So what I can do is try to swap chips with the Space Zap one and see if it's a chip, like one of the customs or something, I don't know. So fire it down, turn it off. And I'm going to remove this bracket so that I can remove the Space Zap card and try swapping some of those two big 40-pin customs and try to narrow down what's wrong with this thing. Okay, this is a bit of good news. This board, this CPU board is the Space Zap board with the 340-pin chips from the Robby Roto board. Here's the Space Zap chips right here. And it works. So those 40-pin chips are all good. It's just a problem on the board itself. which I think I can start by replacing the 3 sockets. That's a good start. So I'm going to do that. I'm going to pull this out of here. Though I know these chips are good. These are the Robby Roto chips. So that's really good that those are good. So okay. I'm going to replace those 3 40-pin sockets. Okay, we're going to start. You know what we're going to do first and foremost? Let's make sure this 245 is good. That's easy enough, right? Pop it in the old tester, and it's good. Well, we get a good reseat on it anyway. Okay. So let's remove. Oh, there's a stupid bullet cap. 2 of them. I forgot to remove them. Come on. Looks hot. Looks like it got hot right there. Ouch. Okie dokie. Yeah, we're going to remove these guys right here. Okay, I got to get the desoldering gun out, remove all of these pins and these 2 caps, and then I'm going to do the rest of the bullet caps. I forgot all about them things. Alright. I'll be right back. I just heard Boo Boo. My cat wants in, so I'm gonna let her in. Let's go let the cat in. Come on. There you go. Alrighty, I'll be right back. Okay, I have replaced the sockets on the Robby Roto CPU board, and it now works. It must have just had a bad socket connection, obviously. Okay, so now what we know is the pattern board, the CPU is good. We know that both the RAM cards are bad. So now that we got these boards working, let's try the memory board and the game board and see if Robby Roto comes up. Okay, so I have put the Robby Roto game PCB and the memory board in and turned it on, and we get nothing. So what do I want to do? I think what I'm going to do is I'm going to swap these things around. I'm going to put my CPU board up front so that I can put the fluke on it and see if I can read the ROMs on the ROM board. That'll tell me if the decoding's good. And the decoding, I'm pretty sure, is on the ROM, on the memory board. So That'll be next, is hooking up the fluke and checking this thing out. Okay, I've printed off some fluke stuff. I'm going to fire up the fluke. And let's go ahead and set it up. Okay. And let's fire up our game board set. Okay. Board is on. And let's do a bus test. Bus test is good. Let's try some RAM. 4,000 to 7 FFF. Let's do RAM 4,000 to 7 FFF. Okay, it's giving me right off the bat FF bad bits, read write error. So can't speak to any RAM. How about E000 to F. Same thing, nothing going on. You know what I'm tempted to do is I'm tempted to put in, you know what, that's what I'm going to do. Let's turn this off. Stop. Turn this guy off. What I want to do is put in Space Zap and run these tests. Just to verify, yeah, this works. I don't need that plugged in for this. So we'll take that board out, and we'll take the ROM memory board out, and we'll put in the Space Zap memory board. Okay. There we go. Now let's fire it up again. Fluke first. Okay. And game board. And set up. Okay, auto test is good. Now let's do that RAM at 4,000 to 7 FFF. And it does the same thing. So I don't know what's going on here with this. Is 4,000 a valid RAM address? I don't know. I don't know what the deal is with this thing. To see, it's running. I knew that the You know, Space App might... That's weird. Yeah, the Fluke just has a hard time running this game, this board set, I think. Yeah. You know what I can do is I might do a learn on this. I'm going to learn, that'll tell me what the RAM actually is. The 2 RAM cards are what I'm really interested in. Learn at 0 to FFFF. Alright, this is going to take a long time, so I'll be back. Okay, I printed off Space Zap of ROM Fluke info, and I'm going through these ROMs, and I'm on the 4th one, which starts at 3000 to 3FFF 6D93 6D93. These are all good. My guess is that this hardware has some kind of funky RAM addressing, and I don't know if it's with the data or if it's with the addressing. It's probably the data, because I get back bad FF data every time. So there's probably some weird system of how this handles RAM data, and the Fluke don't like it, and the Fluke can't handle it. Because I know, according to everything I've found from TechNet, the website, the Fluke website and whatnot, is you got RAM at 4000 to 7FFF. Well, let's just go to 43FF. You know, that is RAM. It should be RAM. And it immediately gives me FF back bad. So this thing, and you can see the Fluke don't like it anyway. It tries to run it and it gets all crazy. Well, lines through there, you know. The Fluke cannot deal with the RAM system on this thing, which sucks. It makes it ineffective. But I can test the ROMs, because there's no funkiness with the ROMs. So I'm going to put the other boards, the Robby Roto boards, back in, and I will be able to test the ROMs. And if I can get to the ROMs, I can get to them. I can't get to the RAM. It's unfortunate that I can't get to any of this RAM, you know, so... But I did use the Inquisitor, and I know that these RAMs on this board are good. On the memory board, the RAM, the main memory board, they're good. The screen RAM is the 2 RAM cards, I believe. That's the screen RAM, I think. It has to be. It must be. And yeah, I can't get to it with this. It must be handled. It's got to be handled some way that the Fluke don't like. So, all right, I'm going to go ahead and pop the Robby Roto stuff back in, and I'll see if I can at least check ROMs. Okay, now I've got Robby Roto put back together, and I've got the Fluke on, and I will turn the board on, and let's do the setup. Bus test is good, and let's do ROMs. ROM at 0, 2, and that is 9286. Let's see what it says. I gotta believe that this won't work. Okay. And EF6D. EF6D. I'm repeating it and see if it gives me the same thing. EF6D. It gives me the same thing. That tells me EF. Okay, it's giving me the same data back, which means it's getting the same thing from the ROM. It could be a stuck bit in the data coming back. It could be an addressing issue going to it. It's getting, I mean, as far as this is, it's working as far as it's getting the same thing back every time, which it's not a random failure. It's the same set failure every time. So I'm going to do just a couple more. And this is B104. B104. What I'm going to end up doing is taking the fluke off of this, swapping the boards around to where, well, I got to look at the schematic and I got to look at decoding. This is a decoding issue, I believe. Maybe the ROM's not getting turned on right, or something funny's going on. And it's giving me EF6D. That's the same thing. It's giving me the same thing. I'm going to try one way up in the range. (52A8). This one's like way at the other end of the range, the address range. And it's giving me the same thing. So, it's giving me the same thing every time. EF6D. I wonder if that is... if a lot of times with ROMs, if you take them out and you're just getting FF back, it'll be a set number. I wonder if that is the set number with all data bits being FF. I don't know. But this could be a blown out chip, or you know, I don't know. It could be, though. It could be. I don't think it's a data chip. I think it's decoding. I really do. I think that the decoding is failing and no ROM is even being turned on, and it's getting FF back. That's kind of what I'm thinking. That ROMs are not even being accessed and it's just bringing back FF is what I believe is happening. So I got to look at the schematic. I'm going to find out where the decoding is at. I'm going to flip these boards around and have whatever the decoding is I need on top, because I need to be able to probe it. So let me check out some schematic stuff and let's find the decoding circuitry, because that's where we're going to look, and that's where we're going to find our problem. So we will be back. Okay, it's set up to do some probing. I'll be probing around this baby. I looked at the schematic U8 and U9. These two guys right here are the 139s that decode and fire all of the ROMs and these RAMs. So, but all of the addressing comes up through these 244s, and I bet you this is the data back and forth. I didn't really look at the schematic that good. I just kind of got the general gist of it. So what I'm going to do is just, first thing I'm going to do is I'm going to probe these, all of these buffer drivers. And it's low and high. You can see the reset. Where it resets, it just goes high. Okay. And this is the enable, which is always enabled, it looks like. And direction. Okay. Yeah. Okay. So we're getting activity through this guy. I know this chip's good. I put it in my tester and it said it was good. So I'm just kind of checking around. I'm just probing around. Basically what I'm looking for by probing these, because I know these chips are all good, I'm looking for floating. I'm looking for floaters. That means there's a bad connection, broken trace, something. Because of the nature of this board set, how it was corroded and whatnot, I'm curious about broken traces. Okay. What I'm all right. I'm pretty confident this is all good. This is going to be all good. Uh-oh. Uh-oh. What in the heck? There's a floater. That is enable, but that's a floating signal right there. Okay. That's the other side of that. Oh, there's another floater, but then it goes to not floating. And there's another one. Okay. Well, there's definitely something to look at right there. That's just floating. we got some issues with some signals for sure. That's not being enabled. That's not being enabled. Okay, it looks like we have issues on this board with signals coming in and out. I got to look at what these are, but we've got failures in signals going through these buffers, these driver buffers, I think. So, yeah. Okay, I'll be back. Got to do a little studying. Okay, this is what I have learned from looking at the schematic. This guy right here is the data buffer. 8-bit data buffer. These two guys are the 16-bit address buffers. These are from the CPU board. I believe this is the upper, this is the lower 8 bits. This 244 is the buffer is the driver for all of the control signals. And this guy gets a lot of control signals. This bipolar ROM right here. This bipolar ROM gets control signals, a lot of them that come from here and from a couple address bits. And what this thing does is this is a decoder. This thing gives off five output bits, 4 of which enable these two guys. You know, there's 4 selectors here. There's one on the high side, one on the low side, on both of them. So that's 4 enables going to this. Pins 1 and 15 are the enables to these guys. So this thing is sending 4 bits to enable 4 selectors, and these select the ROM and RAM. That's what they handle. This thing's 5th output is the direction for this guy. So whether this thing needs to be sending to RAM or reading from RAM or ROM. So what I'm going to do is put this back in here, and I'm going to start probing. I want to probe this again. Now that I know what everything is, I want to probe everything carefully and find out what's going on. So let's do that. Okay, I've already probed one of the address buffers and it was fine. I'm going to start probing the other one from input to output, and you'll be able to see on the scope. Here's pin 2 as an input from the CPU, and it's driven through this pin. Okay, input, that's from the CPU. Why is that like that? Alright, hold on a second. I just turned it off. I want to reseat this CPU board. I know this CPU board is good. Alright. Reset. Now let's fire it back up. Oh. Same thing. What is going on? That is an address bit. Alright, I'm going to turn it off, and I'm going to remove that chip, and I'm going to fire it back up and probe that pin. Okay, that's from the CPU. That's from the CPU. Why is that like that? That makes no sense. Okay, firing it out, turn it off. I'm going to remove this board. Okay. I'm going to remove this board. I'm going to put this back in without the game board. I'm going to turn it on, ground my scope, and probe. And the same thing. Huh. That makes no sense. Okay. In. 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 Okay. In. 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 That's where it goes funky. Why? It doesn't make any sense. There it is, right there. Turning it back off again. I'm going to put it down. Yeah. How much you want to bet? See these 8 away. I'm going to have to do a little bit of repairing on that. That's not corrosion. I don't know what it is. I did not sand these. So I did not do that. I think it's just, I don't know. They just kind of, but I believe that's the one right there, and there's barely no continuity really. I'm gonna see if I get continuity through these. No continuity. That's got to be the one. No continuity on this. No continuity on this. Wow. Yeah, let me let you take a look at what I'm doing here. Okay. If you can see, I have this set to, okay. Just going and checking the pads to the vias. Okay, good. No continuity. No continuity. No continuity. Where does that go? Over here someplace. That's a data bit. Okay, good. This is another data bit. And another. And another. Okay, good. Alright. No continuity there. So we got about what, 3? Good. 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 That one was bad. This one's bad. So there's about 3 bad ones on that side. No, goodness gracious. Let's check this side. Good. 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 Okay. This looks like it comes up over here. Good. I need to put that chip back in the board. Okay. Alright, where was I? Where was I? Where was I? Yep. Okay. The other side is on the back, which I tested, which is that floating stuff. Okay. That's good. That's good. That's a big thick pad. That's good. Good. Okay. Good. Okay, so alright. There's 3 of them on the back here that are broke, but I'm going to reinforce all of these that look crappy. And then we'll see what we got. Alright, I'll be right back, guys. Okay, and you can see what I did here. Easy enough. Just little leads from capacitors that I save for reasons like this. Whenever I do cap kits and stuff, I always save a certain amount of the leads that I clip, because you never know. And here we go. I needed them. So this is what I did. You can see those ones are fine. So now all of our connections are good. So let's put it back together and see what we get. Okay, I am hooked all back up and powered on, and we're making progress. See that? It is now just resetting, but it's trying to run. Yeah, it's trying. Cool. Alright, I think I'll reseat everything. I'm gonna stand this up and try reseating everything and see what happens. Okay, I stood it up and I reset all 4 of these boards. And this thing is running, it's working. How freaking cool is that? So I think I'm going to hook up the sound, hook up my speaker. Yeah, she working. Yeah, I'm going to go ahead and do that. I'm going to hook the speaker up and put some sound to this thing and play some Robby Roto. Well, I just realized I never put in start 1 and the start and coin wires. So I'm going to have to do that really quick. I forgot all about that. But I did hook up the speaker and you can hear it. You can hear it, so I'm pretty sure it's working. So, pretty sure the audio's there. But it's still going good. Robby Roto. Alright, let me go ahead and put some more stuff in here. Coin and start, and we'll get it going. Okay, so I just went ahead and put in my coin and my start wires and got it turned back on. It's running just fine. So I'm going to set up the camera and play some Robby Roto. Alright guys, you ready for some Robby Roto? Let's do it. Here comes a coin. Alright, and start. Here we go. It's another noisy one. Let's do the magic button. Oh, I didn't see him. Robby Roto. kind of difficult to see what you're doing. That was a weird noise. It's another noisy one, and it's kind of hard to see what you're doing. You really need this in color. This one you really need in color. Hey, I'm 12th best. But how about that? Robby Roto. Turn the lights back on. You know what I forgot all about? This is the Space Zap RAM cards. So even though this was an awesome playtest, we still have bad RAM cards down here for this game. And I don't know of a good way of testing those. I can't get at them in here. What am I supposed to do? Just replace all the RAM? You know what I could do? I might have to do is, I'm telling you guys, I'm going to have to remove all of those and test them in my Inquisitor. I think is what I'm going to have to do. You know, I don't know how else to test them. Is there a... Robby Roto doesn't have no test ROM, does it? Not that I know of. Space Zap doesn't. You know what I want to do? Let me put this into test. You know what though? I read something on this test. Alright, let me take it out of test. You actually have to restart it. Take test off and restart it. But what I read something on the self-test on this game does that where it says 1, 2, 3, 4, or 5. If it passes, it won't have a message after. It's like test 1, test 2, test 3, test 4. And then test 5, it just does that tone. It was for operators to set the volume. That's what test 5 is. It's just an audio tone. And then, so this thing passes all the tests, but in the manual, I read in the manual on this game, and it says, it's like test 2 or something like that, tests the screen RAM, and it'll just have a message that says bad. And then in the manual it says replace bad RAM on RAM cards. That is in the manual. So that basically helps none. Not at all. So there's just not a good way of testing these unless you got a Gorf and you've got the test ROM. And I don't have a Gorf. So yeah, I'm going to do a separate, I'm going to end this video because for all intents and purposes, this is good other than the RAM cards. And the RAM cards are simply just me going through and removing all the RAMs, testing them, finding bad ones, and putting good ones in the board. You know, that's really all it entails. So I might do a separate video on rebuilding RAM cards for the card rack system. I'll do a separate video for that. But the Robby Roto video I'm ending here as good to go. So as always, guys, I appreciate it. Thanks for watching, and we'll see you on the next repair. And I will be doing a video. I'll film the RAM cards, rebuilding the RAM cards. I will film that. So, you know, keep your eye out for that one. We'll see ya. Thanks, guys. Okay guys, I thought it was over, but it's not. About an hour into the burn-in, I noticed that my score I put up was gone, so I knew it reset. And then I tried starting a game and it just flaked out and was flaky. So what I'm going to do is I'm going to clean up from here over. This whole area over here. So I'm going to remove everything from this line over. I'm going to clean these traces. I'm going to clean everything over here. And I'm going to replace everything over here. Because I know it's this board. So that is going to do it. That's what I'm going to do. I'm going to clean up because this does look kind of nasty. And I've kind of already made a little map of what is what. U3 I can't read it, I don't know. I'll just look at the schematic, find out what it is. But yeah. Cleaning up this area. I'll sand down all of the corrosion and stuff and replace all of this stuff. Remove these caps I put in, remove that, all of the caps, everything, so that I can clean this stuff up. So that will be next. I thought I was done, but I'm not. So I'll get to it. Hi guys. Well, we're back. A good Samaritan viewer was viewing my video and saw this and sent me this. And I'm glad he did because I can't see this. I'm almost 50 years old and my eyes are not what they used to be, even with the glasses. But this is a nice blown up picture of my video, and you can clearly see that crack there? You see that crack? See that one's cracked? That one I can't tell if that's a crack or if that's just a shadow. But those are obviously cracked, and if I move over, can I do that? No, I'll have to come right back. I'll pull up another picture. I'll be right back. Okay, and here is the other picture. If you look over here, that is, see that? Then pan over. It's got 3 little spots on it. And see that? So I'm going to go ahead. This is on that memory PCB, the same one that I found the other problems with. So I'm going to go ahead and I'm going to just jump every trace. Not jump them, but I'm going to make sure that every one of the connections is made solidly. So I'm going to do that. Let's do it. Okay, so I did go through and I redid all of those connections that looked funky. Well, I did on the back side of the board. I'm going to closer examine the front side of this board because it's still flaky. You know, it was working good, but now it's not. Now it is doing this. I'll show you. You coin it up. And then you start and watch. Totally flaky. It'll do this a couple of times, 2 or 3 times, and then it'll reset. Just like that. So I'm going to check the top side of this thing and make sure everything looks good here. Okay, guys. I don't see anything wrong with the top side of this board. Hello. Get out from back there, you idiot. Live monitor. Goodness gracious. That was fun. All right. Where was I? Okay. This thing's still acting flaky. So, see this area? I don't like this. It is suffering some corrosion. See that stuff? A little bit of green right there still. This is all good right here. But up in this area, still a little green. That's not terrible. More ROMs. I think I'm going to remove from here over everything from right here. I might even remove all these 10K resistors and clean that area up. But I'm definitely removing everything right from here over, and I'm going to clean up this area and down into here. I'm going to replace everything over here, all the resistors and caps and everything, just clean from here over. And I probably will do this stuff too. And I'm going to take and do a light sanding, like a wet sanding almost, and remove this corrosion crap that's up here. Try to get that off the board. Do another little vinegar wash over this portion. Replace all of this, and then see what we got. Because I just don't like this. I don't like it from here over. So I'm going to do that. Alright, I just kind of wanted to put a little bit of a charge into the battery and let you guys see what I'm doing here. I've already desoldered these chips. And I'm putting all my stuff that I take off the board in here. I'm cutting these capacitors and stuff off because the pin leads are like folded over underneath, and it's easier to just cut everything off and do the old pick and pull. But this board is nasty through here, and this needed to be done. I'll give you a nice close-up of it when I'm through with this, but yeah, this had to be done. So this board is nasty through here. I'm doing all of these 10K guys too. Okay, these guys are okay, I think. Yeah. So now we're going to pick and pull all of these little leads. I'm going to tin this guy up really good. It's always good to suck up some fresh solder. Find a good ground plane. Suck some fresh solder into this thing, and it's well tinned now. There's a little tip for you today. That's what I do all the time. My repairs, you'll see little solder spots like that from when I do that. So, okay, we're going to start picking all of this garbage out of here. Let me answer this really quick. Okay. Alright, let's do this. I'm going to grab this guy. And let's get to picking. You know what? Nope. Let's do this first. Come on. I do not want to suck these things up into the soldering iron. I can't do that. I don't want to suck these up into the iron. So this might go out of frame, and I apologize. I'm just going to back it up. You're not going to have a good view, really, but you'll get to see what I'm doing at least. I'm going to grab onto it. Well, this one I desoldered. Kind of. That one I did. And that one. Okay. I might be able to do this top side. Yeah, I can do this top side. Yeah. You son of a bitch. Yeah, that's just getting to be too corroded. I should be able to get it from back here though. It's a lot of picking and pulling, I tell you. Just make sure it's flowed good before you pull it out of there. Okay. We're cruising along now. Cruising right along. I'm going to take a break to clean up my mess. Got a lot of leads pulled out. Get them out of here. Okay. And we're getting there. Got all these 10K guys to get yet. Might be able to get them from the top. Maybe. If you're doing this and you can't see that solder actually flow and see the pin move, do it from the back side. And when you're dealing with boards that are this bad like this, if you're got the vias, there's nothing connected on top side, and you happen to pull the little pad up off the top, if there's nothing going to it, I don't stress out about it. When the boards are like this, I mean, sometimes there's just nothing you can do. flip it over and do the other side. Okay, I believe we're done with the pick and pull. I think. Take a look. Oh, there's one. Come on. There we go. Gotcha. Nasty. Ooh, good catch. all of these top pads are going to come off anyway. When I clean this, they're all going to come off. So it doesn't really matter. That one just came off. Actually, it didn't come off. It was just a ring of crust. Don't you get up there again. No. Oops, ow. Okay. Alright, that's done. Oh, sheesh. So I'll bring the camera down and let you have a look at the board. Get this crap off. Ow, 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 that's hot. Ooh, 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 that is hot. Ooh. I can't put that in the trash just yet. It's too hot. All right. There's a RAM. Oh, let's turn this guy off. Okay. Here's where we're at, guys. I'm going to clean all of this off. This whole area. So what I'm going to do is I'm going to remove everything off the board, all the RAMs and ROMs and these socketed chips. I'm going to remove all that again. And I'm going to take some sandpaper. I'm going to wet this thing down a little bit, and I'm just going to sand it lightly when it's wet to kind of just remove until all this crap is removed. And then I'll give it another little vinegar bath. And then we should be good to go with this thing. Finally. Okay, and here is the board after stripping, a little light sanding, wet sanding on both sides. And I'll just kind of show you. I think it came out really super good. In the back side, I got to repair that right there again, but yeah. No more corrosion. Yeah. So this thing will be repopulated and ready to go. And I'll make sure I'll go through and do continuity tests, and anything that looks suspicious at all, I'll beep out. But yeah, it should be pretty straightforward. All right, everybody. So it looks like we're going to start part 6 of this series. First thing I'm going to do is put... Where are my glasses? Oh my gosh, I think I left my glasses at work. Well, I can use the magnifying glass. I want to beep out, just kind of go around beeping around stuff that might look suspect. Just make sure everything's good to go. I believe everything is. I kind of once over the board here, and I didn't see anything that looked broke. Everything looked okay. So we're going to work on repopulating this baby. Yeah, so that'll be fun. That'll be awesome. I have a little list. Oh shoot. I had a little list I will have to find of, you know, what's what parts. It's around here somewhere. I'll find it. Yeah. So I'll do that. I'll find my list of parts that I removed. Nice and smooth. This board came out really good. Clean. Now it is officially really corrosion free. So let's go ahead and find the list of parts and start gathering parts. Okie dokie. Got our parts list. Got a collection of parts along with all the chips. Okay. I think I need to change the tip. I do. And let's go with this guy. Turn it on. Okay. And, well, let's do the caps first. Ouch. You know, I so need my glasses. Is this going to be right in your way? Yeah, kind of. Not terrible, I guess. Right? Yeah, that's not terribly in your way, is it? No, you can still see what's going on, I think. I do have to kind of pull it out of the way. Just solder it top side. Solder's flowing pretty good on there. Nice. And our first chip, our first part is in. This would be actually kind of cool if I ever got set up to do it. I'm not that savvy about this kind of stuff, but this kind of stuff right here would be kind of cool to do a live stream. You know, just sit here and do this and check and see if people are chatting and stuff. I need to get into that and figure that stuff out. Guys, I don't know about doing that stuff. I'm not good with that kind of stuff. But I'd like to. I think that would be cool. I like interacting with you guys. I think it's really cool. That way you can ask me something if you see something. Maybe I can answer. I don't know. Did everybody have a good, what is today? Tuesday? Everyone have a good Tuesday today? I did, not too bad. This is really good. The solder's flowing really good. You sand down that junk, you know, you get that nastiness off of there. The solder's good. Good connections everywhere, good parts. Nobody wants boards that are all corroded out, you know. They drop right in nice. Fold those leads over really good. Darn it. Darn it all. You know what I'll do? I'll try keeping this thing up out of the way and put some Coke bottle glasses on. These I call them my Coke bottle glasses because they're like 3 times magnification. 3.5 or something like that, crazy. So I can put those on and get right down in here. But I have to be right down on it, otherwise it hurts my eyes. These are 0.1 microfarad. You look on the original caps here, it says 104, and the 4 in that is the multiplier. So you have 10 and 4 zeros. So 10, and then it's like 100,000 picofarad is 0.1 microfarad. That's how you read those things. And you just kind of, after a while, the codes are always in picofarads, unless, not always. Sometimes it'll be stamped UF, you know. Like it'll say 47 UF or something like that. Electrolytics. These little guys right here, these little codes are always in picofarad. Like 104, that's 10 and 4. That's 100,000 picofarads. Yeah. Then you see something like 473. That'll be 47 and 3 zeros, which is 47,000 picofarads. Which will usually be abbreviated down to like point, maybe, I don't know, 0.0047 microfarads or something like that. Something like that. Capacitors. There's one. It's like 12 of these guys. Decoupling capacitors. Okay, looks like we got one more. And I see I need one right here. Decouplers. That's a resistor, capacitor, emitter base collector. Let's do this guy. NPN transistor. There's a diode right here. A rectifier. Okay. Resistor, cap, cap. Resistor, resistor, resistors. Resistor cap. And all these chips. This one looks like shit right here. That one looks like garbage up in the corner. It'll be okay. You know. Okay. Alrighty. I'm going to take a little bit of a minute. I'll be back. I'm actually going to do some more of it off camera, like all these resistors and stuff. I want to go ahead and take care of all the resistors and stuff off camera. Okay, and our board is put back together. Make sure everything's in the right orientation. And all of these are good. These two guys up here are looking good. Okay. This chip right here I did not have, so I'm using the old one that I removed. I hope it's good. I did order some. I ordered 20 of these. So it's a 4078. It's a 8-input NOR gate, which is something. It's an oddball thing. I don't have any. Yep, but this bipolar ROM is, yep, notches in the right spot. So it's looking good. It's all repopulated. Look at the back side. It's all looking really good. I ran a little jumper from there. Just a little jumper. So I'm ready to put this thing back in the cage and fire this thing up, and hopefully our woes are taken care of, right? I got all these resistors here looking really super good. Yeah. All right, let's do it. Let's put this thing back together. All right, and we're looking good. Board's back in. I ran audio 2. As I spoke with Matthew Janicek. I'm not sure how to pronounce your name, sir. Sorry. And I was informed that audio 2 is the second custom chip on the game PCB, so I should check that too. So I have wired audio 2 into here, so I can test both audio 1 and 2 now. And right now I am on audio 2. I've been testing audio 1 right there. This is audio 2. So, and we are running And not only are we running, I've played a game, and it actually is working. I don't know if I elaborated on why I did this in the first place. Number one, I wanted to do it. It was bothering me because it was corroded. Number two, this thing was kicking back a NVRAM error. It was saying that this chip was bad, and I knew this chip wasn't bad. So it just wasn't getting to this guy. And there's circuitry over here that enabled this RAM. That's what prompted me to say, okay, I need to go ahead and clean this up. So that's the main reason why I did that, but I wanted to do it anyway because it was corroded. There was corrosion there, and now there's not. So, and now it's got new parts. Man, this board right here is redone. It needed to be, though. It was trash. It was absolute trash. But I'm going to go ahead. We'll fire this thing up. I'm going to set the camera up, and we'll play some Robby Roto. And then I'm going to let this thing run for a couple of hours and then call it good. So let's set up and play some Robby Roto. Okay, we're all set up. We got the lights out a bit. And you'll remember when this thing would mess up, it was right at the beginning. It wouldn't even start the maze. It would reset. Remember how it would try to set the maze like 3 times and then the game would reset. So now let's check it out. And this is the second audio channel. So we are testing the audio out of the second, I don't know what they call it, the Astrocade chip. I'm not sure. I think that's what they call it, though. It's basically kind of like Midway's version of the Pokey chip, because it does input-output, it does controls, and it does sound. So it's kind of Midway's Pokey, if you will. Anyway, let's go ahead and start this thing up. Yep. This is audio 2. There's obviously not as much going on. That reminds me of Zookeeper. Oh boy. Oh boy. Those sounds really remind me of Zookeeper. I like this game. I could see playing this for hours. See, this accompanied with the other chip make all the sounds. The other one makes the walking sound and that kind of nonsense, you know. It's really, really loud. that thing killed me. See, I didn't know if that thing could kill me. All right, let's switch over to audio 1 again. Okay, and let's coin the thing up. This is the loud audio channel. Oh! Oh! Oh, come on. Darn it! This is hard. Well, it's hard when you can't see. You need color for this game. It's pretty cool. I like this game, though. But yeah, I believe we got it, guys. I really do. I do. Good, nice, clean, zero corroded board now. I like it. All right. All right, I'm going to hang out here with this thing and leave it on for a while, and we'll come back. I'll come back to you in a couple hours. Hopefully my my score's still there. Let me put in... Oh, I didn't put anything in. I was on the board, though. I want to wait and see if my score's still there. It was like 16th or something like that. That's a good way to tell you if these things reset or not. Is put a score on there, and then you just make sure your score is still there. You don't have to sit here and watch it constantly. That's what happened last time I had this thing going. Yeah, see my scores? 16 and 18. My two scores. Yeah, see? Alright. I'll see you in a couple hours, guys. Well, as you can see, this thing has died on me, and it's in a stuck reset. And I'm not exactly sure what's wrong with it. I'm not 100% positive that it's this guy. But it could be my decoders. Remember, I did not replace those guys. Could be this bipolar ROM chip. I was suspecting this guy, but it's fine. I'll turn this off and go back to Logic Analyzer and just kind of repetitive run it. And it's a NOR gate. It's an 8-input NOR gate. And basically, the only time a NOR gate is going to be a 1 is when all of the inputs are 0. Any other combination, you throw a 1 in here, it'll be 0. So that makes it easy. The NOR gate only goes high when all inputs are 0. So I'm just triggering on 0. And you'll see every time I get a 0, I get a pulse. So that thing is working just fine. I'm going to move on and suspect these guys because test does nothing. This thing is dead. So I'm going to suspect these 139 chips, first of all, because test does nothing. So, and I've already probed all of these guys, and everything looked fine here, all these buffers. So next thing I'm going to suspect is these guys right here, these 139 chips. Okay, as you can see, the fluke has come back out. I did go ahead and I replaced those two 139 decoders on the ROM board as a shot in the dark, and it did not make a difference. But hey, I got 2 new chips on the board. So I'm going through the fluke, and all I can do is this guy, this guy, this guy, and this guy. When I get to these upper address bits, they're all bad. All these are bad. These ones are good, and then they're bad from there on out. So going into the upper address range does not work. But I can do a ROM at 0 to this, and it's 9286, 9286, and that'll be good for sure. But all of the ROMs in the upper address don't do it. That one's good. Now we'll go to A000 to AFFF1002. We'll go to A to AFFF1002. Go. And this will fail. Okay, and not only, check this out, go more, 7A06. Let's do it again, repeat, 7A06. It'll give me a completely different number this time. That's just random nonsense. Random whateverness. Yeah, see? ED6E. So this is just not decoding correctly. It's not a data error, so to speak. I think it's just a complete failure to address, decode. So I'm going to have to look at the schematic again and look at these upper address ranges and see what's going on. How come the lower address, the lower 4 address chips are okay, and then the rest of them are not? So that's what we got to look at. All right. back to the schematic. You guys are the best. I mean, I swear. You know, I should have caught this. I should have seen this. Senali Deluxe. Cut trace between that is 8 and 9. That's pin 8 and 9. Right there. That is pin 7 going between pin 8 and 9. And that is the second chip down. Right at the point of this. You know, right at the point here. So that's pin 7 going between 8 and 9. So if we come over here, and you know what I'm going to have to do is grab this guy, because I can't do this one-handed, and put this on there, right? And I need this guy because it's got the clamp, you know, the clips. Just kind of, come on. It's tough to do one-handed, guys. And let's put this on beep. And select. There we go. Audio beep. Let's put this to pin 7. Right like that. And let's take this, and it's this trace right down here between 8 and 9. And if we see that, that is supposed to be going right here between, there's no continuity there, you know. So I am definitely going to fix that trace, and then hopefully that'll make it to where this thing will read the ROMs. You know, go through the ROMs and stuff like that. So I think that's what I'll do. Let's fix that trace, pop this thing back in there, put the fluke back on it, and see if we have all of our ROM ranges. Because if you remember, last time I was testing, I could test, these guys were okay, but the upper address chips I couldn't read. So I don't know, let's check that out. Alright, let's repair that trace and come right back. Okay, and here is the fix. That pin connects right here. So I got a little wire wrap wire going around, making its way to there. And I will flip this guy over. Yeah, it's right there. Come on. Nicely tucked in, and it is not shorted to this. I've already checked. So yeah. So now let's see if we can read those ROMs. You know what? Let's find that on the schematic and find out what that is. Let's find out what that little trace, what that did, what circuit that it's involved in. Let's do that. Okay, we are hooked back up after repairing that trace. Hooked back up with the fluke. And if I go right into ROMs, let's do A000 to AFFF, and that is 1002. And let's try it again, repeat. And I'm sorry, I did not go to the schematic and find out what that pin did, but we will do that. I just jumped right into testing this, and it fails. And we're going to get 79D4. 79D4. Let's try it again. I wonder if this address range is just not accessible by the fluke. I don't know. Because 0 through 3FF is fine. And it came up with something different this time. 039F. It's just getting... It's like nothing's being accessed properly in that upper range. So let's stop this. I want to look at what that was. That trace that we fixed. I want to look at that, what that was. And I also want to see what is the difference between the lower 4 ROMs being turned on and the upper 6 ROMs. What's different between those guys? Why can I do the bottom ones but not the top? You know, that's kind of what's throwing me right now. So let's just look at the schematic and kind of try to figure out what's going on. Plus I'm curious to see what that gate was that that trace was broke. And that trace was broke when I first put this thing together, and it was working. So what was that all about? But you know what? When I did put it into a test, I was getting a failure about something with RAMs. It was giving me RAM 5 and 6, or test 2 was giving me 5 and 6, which I looked it up, and it was some RAM thing, I think. I'm not exactly sure. But it was still running. It was a memory protect or something like that. That's what it was. Memory protect. But so that would probably fix that. But this is a different problem. The memory protect failure in the test that I saw before, which I don't think I filmed, is probably what that broken trace fixed. But this is something totally different, and I'm hoping it's not that programmable logic chip, the decoder. It's a decoder. You know, that's not a bipolar ROM. That is a PLD, programmable logic device. And if that's bad, we're screwed. You know, and I know that is what selects the ROMs. That's what enables the selectors, is that thing. So let's take a look at the schematic and just kind of look it over. Okay, this solves the mystery of why I was getting that error 5 and 6, which was the memory protect failure. This is that gate right there. Pin 6 was the output, and that's the trace that was broke. This trace going up was broke. It goes up to U4 on pin 8. And then that, in turn, goes into this guy. And that output, in turn, goes into this guy. That output goes all the way up here. And and enables the RAM. That's the That's the NV RAM right there. It's the chip select, or the output enable for the the whatchamacallit here, NV RAM. So now to look at our decoding. Let me see if I can do this like this. Just kind of maneuver this thing. Let's go up. And X, 9, and 10. Those are two ROMs that we cannot access. This guy right here is that little jumper thing. X32. That's fine. Address 11, is it? Yeah, that's address 11. Goes through, and address 11 is pin 18. So that's fine. These are our problem right here, these chip selects. They come down, and they come down, and they go over, and they go over to this selector. Okay? I know these selectors are good. These 139s, are nothing wrong with them. They get enabled by this guy. Field Programmable Logic Array. That guy gets a bunch of control signals, which I'm sure those control signals are there. This thing also enables the 139s that fire the other ROMs. If you come up here, the first 4 ROMs, 1, 2, 3, and 4, are also fired by 1, 2, 3, and 4 are activated by U8, the low side of U8 right here. Okay, and that gets activated by pin 17 of this guy. So pin 17 is fine. It's doing its thing. Now this line is pin 16. That is supposed to activate this guy, which turns on X 5, 6, 7, and 8, which is not happening. Okay. And then pin 14 and 15 come over and activate these guys. Yeah. That's pin 14 and 15. Where's this guy go? He also goes up way up. I lost him. I think he's activating this guy, maybe? I don't know. Yeah. Okay, he is right there. Oh! Darn it, I keep losing it. I think it activates... Okay, all the way to the left. It goes over here and goes through there, which is strange. I don't know. I need to look at this off of the cameras. I can't hardly do this. But it's looking like it might be that field programmable logic array may have died. And if that is the case, I don't know what to do, guys. Because it was running fine. It had that error. And that's what that trace, I guarantee you, that trace that was broke, that fixed that error. This thing was chugging along and running fine, and all of a sudden now it's completely dead. Won't do a thing. So I believe that that field programmable logic array died. And I don't know what to do about that. So I don't know what else it could be. I think what I'll do is I'll just probe around on the board a little bit and make sure that everything, the signals are all good. And if the signals are all good and I can't find anything blaringly wrong, then I'm just going to say it's that field programmable logical array. I'll make sure that those are not being accessed. You know what would be really great is if I had an extender card to plug in the memory board while I have the fluke plugged into the CPU board so that I can probe those 139s and see if they are actually being enabled and stuff while I'm hammering addressing and stuff like that. But I can't do that because of this cage. So I'm going to regroup, do some thinking, and I'll be back. But my initial diagnosis right now is I think that chip, that logic array chip is dead, I think. Okay guys, I'm sitting here looking at this chip, this FPLA, and all of these inputs do what they should. All the inputs are toggling good. It's the outputs, I don't know, because right now I can't tell if this is supposed to be firing any of the upper address ROMs. I really don't know. Yeah, I don't know if most of the program hangs out down in the lower address. Probably. You know, I bet you that 0 to 4000, 0 to 3FF is probably the bulk of the program ROM. And the other ROM is like game ROM or probably graphics ROM or that kind of stuff, I would imagine. But it looks like it's all accessible. I can't remember if I tested all of them ROMs with my fluke. I'm going to have to go back through my video and see if I did those upper address, if I was able to read those upper address guys with the fluke. I'm going to have to check that out, as I don't remember. Yeah, so I don't know. This is a stumper so far, but I do have an extender coming. I bought an extender, a card extender, so I will be able to put the probably the CPU board out because it's lighter, and hook the fluke up to it and probe that ROM board, you know, that memory board, and see if that that logic array chip, see if it is actually, see what I'm going to do is I'm going to use the fluke and I'm going to try to read those upper address ROMs, and it should turn on those 139s that decode that signal to turn those on. And if it doesn't, then I know that chip's bad. It's really that simple. And then there's, you got to try to come up with some kind of a solution. Right now I am really suspecting that chip is bad, but I won't know for sure until I get that extender, so that I can do two things at the same time. I can probe that chip while I use the fluke to hammer those upper address ROMs. So that's the plan, Stan. So that's going to do it for this this section of this video. I've got to wrap it up because I can't do anything until I get that extender. in the mail. And when I do, we'll be back for another part and more testing. Yeah, just a little thinking out loud here, guys. We have 4 ROMs that I can read. No problem. Every time, 4 of them. The first 4. X1, X2, X3, and X4. There is nothing special separating X4, X5, X6, X7, X8, 9, and 10 from 1, 2, 3, and 4. They share the same address bus. They share the same data bus. They have different decoders turning them on, but those decoders share the same chip. Let me rephrase. They share the same source for activation. That U10, that field programmable logic chip. 139s, there's 4 139s. There's actually 2 chips, but there's 4 selectors in those 2 chips. Only one of the 4 selectors is being successfully turned on from U10. The other 3 are not. That's the only difference. So what I'm suspecting is happening, and this is what I'm going to find out when I get my when I get that extender card. I'm expecting to see no ROM being, those ROMs are not being fired, is what I'm expecting to see. The chip select is not going low. So what that tells me is whatever is lingering on that bus, because everything is staying tri-stated. This is a weird system. I just got to looking at this, and the data bus and the address bus are shared. So this depends on everything to tri-state. Whatever's not being selected is tri-stated, so that one device dumps to the bus and is read. Or one device is turned on to be able to be written to, such as the RAM, so that whatever's on the bus writes into whatever's chip is selected. So what I'm suspecting is happening is when my fluke is trying to read from these ROMs in the upper range, and this is why it's getting back erroneous data every time. It's because everything is tri-stated. And the fluke is interpreting whatever it finds on that bus. Okay? Whatever is lingering on that bus, whatever floating nonsense, whatever it finds. There's nothing concrete. There's no solid signals. That's why it's getting goofy stuff back in every time. So I do believe, even stronger now, that logic array chip is no good. Which is really unfortunate. But I'm going to verify that for sure, for certain, when I get that extender, because I'll be able to just zoom right in on it, try to access those ROMs and see if that chip, see if the output on that U10 goes low. That's supposed to activate that selector. That's how you tell that. So that'll be next. This one's on hold for a little bit until probably after the holiday. After the Christmas season probably, because I did buy extenders, and I bought a RAM extender as well. So no guesswork. I'm going to be able to extend those RAM cards out and actually probe the outputs. And 9 times out of 10 on these 4027s and 4116s, when they're bad, the output is completely dead. it either floats or it's always stuck or something. So this is a long series, but it's, hey, it is what it is. Sometimes these things just one thing after another. But we will get it. We'll get it. But the hard part, if we verify that that chip is bad, the hard part is going to be tracking one of those down, or how to go about getting one of those. If anyone knows anything about a lead on hobby ROMs, would hobby ROMs have that? I don't know. But anyway, guys, we'll see you on the next part. It's going to be a little bit because I got to wait for them extenders, and that way I can verify what I'm suspecting. And that's it for this one. Thanks a lot, guys, and there will be, what, part 7 eventually, but it's going to be a while. So take care. Merry Christmas, everyone. Happy holidays. Whatever season you celebrate, happy that. Look at this little baby cat, by the way. She just loves me. Always hanging out with me. Alright guys, I am watching my own video, just kind of proof watching it a little bit. 8 and 9. And this part right here comes up. This is the trace that we were talking about that's broken. There's another broken trace right here. And I just was over beeping it out, and that one is also broke. This is the one that the viewer pointed out, but this one's also broken. So there's another one to fix. I'm going to fix that right now and see what that does. Yeah, this one is not quite as broke, but it is broke. So let's fix that one and see if that does anything. It's got to do something. Okay, so we're going to do a little trace work. This guy goes, that one that we were just looking at, goes to this little via right here. It goes through here. It goes through underneath this chip. And it's broke. So I need to jump from this leg to that via hole. So that's what we're going to do. So we'll do the leg first. And just kind of flow the solder up onto it. Like that. And then we will solder our wire to it. I like to tin this wire just a little bit. Get a little better connection. Trim it down, okay, and then we'll solder it to this leg. Just like that. And we'll find a clever little way to route it. Let's go this way this time. through here. Like so. Cut it to size. We'll go right about there. Strip it down. Oh, it broke. I cut it. Son of a gun. Yeah, I might be able to still use it. I'll try to get some slack by going this side of this. And then going underneath that way. And yeah, we've gained a little bit of slack. And I need my tweezers. Okay. Okay. And there we go. Very good. Another trace repair. Now that, I believe, is the last one. This was the bad area up here. So that should be the last one. Now let's hook Robby Roto back up and see if that makes a lick of difference. I gotta think it's gonna make some kind of a difference, right? How can it not make a difference at all? Alright, I'll get the Robby Roto stuff back out and we'll hook it up and see what happens. Okay, that trace has been repaired. We're fired up. Same thing. It's resetting. And if we come over and we take a look at our schematic, you'll see that pin 9 of U1 is an input, and it's part of the circuitry for the, once again, for the NVRAM. So NVRAM should be fine now, because I was having it was failing when I put it into test. Now it should work fine. There was 2 traces that were involved in NVRAM. I still believe that this is that PAL chip, that 82S153. It's a PAL. It's not a bipolar ROM. It's a PAL. And I believe that's the problem. But like I was talking before, I'll be able to verify that it's the problem once I get that card extender, and I can do 2 things at once. I can probe that chip while I try to access that ROM range and see if it is indeed activating those 139s, which I doubt that it is, and I think that's the problem. So we'll see. All right. That's the next big step. That's the next question. That's the next mystery that needs to be solved. And I can't solve it until I get that extender. So, still waiting. Hello guys, and welcome back. It's been a while. It's been a while since we've messed with this guy. Robby Roto. Huge shout out to Matthew Janicek. Janicek, I am sorry. I'm not exactly sure how to pronounce your name, but big shout out. He sent me this chip. This is the old guy. So I got it in there, and we're going to go ahead and I have since got these guys. Remember, this is an old chip, so I'm going to replace that. And this thing will be ready to go. We'll be ready to put it together, put it back in here, and see what happens. Okay guys, I have to do this, and I have a confession to make. Yours truly put these garbage sockets in this board. These things. It's all I had for 20 pin, and I put these things in here. You know, so these are getting removed. I'm going to remove these sockets, and I'm going to end up, this one's okay up here. That's a dual wipe, that guy. I'm going to see what I have as far as 20 pin sockets. I might have some machine pin sockets. But I'm going to see what I got and what I can do, because these have to go. This board will not be solid with these junky sockets in it. So I'm going to replace them. This is a good socket, I already know. I'm going to replace this chip with a new one. So then we will be good to go. This board will be absolutely perfect. So let's do it. Okay, I actually do have 3 dual wipe sockets, and I have 2 machine pin sockets, and I will put those into the board right here. These will be the 2 machine pin guys, and then I'll have the 3 dual wipers, and it'll be good to go. All right. We're going to do some desoldering. Do some desoldering, and I'm going to have me a little sip of my Molson. Pure Canadian goodness. Alright. Okie dokie. Yeah, guys, boy, I put these junk sockets in this board. What was I thinking? I mean, really? It's embarrassing. I should be ashamed of myself. Alright, let's do this really quickly. Oh yeah. You gotta always keep an eye on your temperature thing. This thing likes to move around on me. I keep it at about 2.5. If you have it too hot, look at that, it just fell right out. junk. Yeah, if every now and again I'll find this thing creeping up to 4 as far as the heat, and this thing likes to pull pads off of boards if it's that hot. Robby Roto. This is not the end of the Robby Roto though, guys. We still have RAM problems on this. Remember, both of the RAM cards are bad. You know what's really cool too is with my new logic pack that I got for my 29B, I was able to dump the JDEC file for the PAL chip on this board. So for all of you guys who have dead Robby Roto boards with no hope in sight because you don't have the PAL chip, I got the good file. Dropped right out. I do have the file. I'm going to be doing what I want to do is I want to start documenting and dumping every PAL chip on the boards that I come across that I can. Like, I've got pole position so far, and I've got Robby Roto. I'm going to look at the Tron boards. The CPU board on Tron has PALs or GALs or something. I want to dump everything. I want to dump every one of these logic chips on these boards that I come across that I can. That stuff, there's not good documentation on that stuff. So whenever I do a repair and I come across a board that's got one of them chips on it, I will pull it and I will dump it. Basically any PAL that I can do. Those chips have to be, you know, documented. The files. That way it just makes life easier. Right now we're in a situation kind of where we have to reverse engineer and make a TTL daughter board or something like that for these chips, and that's not ideal. So it will be my goal, my quest, to document as many of them PAL chips as I can. First thing I did when I got this Robby Roto chip from Matt is I put it in my Logic pack and I dumped it, saved the file. phone is getting blown up over there. Alright, these garbage guys are gone. 5. Bye. Just shining those pads up. Cleaning it up. Okay. All right. Robert Roto. Let's turn this guy on. Alright, we've got our 3 guys here. Bear Roto. Alright, let's do these three guys first and foremost. How many of you guys saw these sockets earlier in the video and were like, oh my god, replace those? I wouldn't blame you. It's all I had at the time. It's still no excuse to put bad shit in a board. But we're rectifying that issue. Putting some decent dual wipe sockets in and a couple machine pin sockets. Be good to go. Okay, let's straighten those legs out. And we are putting in 2 machine pin sockets. And I do not like machine sockets. I think that they're just too damn hard to get chips in and out of. That's why I don't like them. But I have some, so that's what I'm using. All right. How am I going to get them to stay there? This one doesn't want to stay put. Alright, we'll go with that. It's just another reason why I don't like these. They're hard to put in. Can't fold legs over. Alright, our sockets have gone from terrible to good. Alright, boy, that is a pretty snug fit. I don't know, maybe I'm wrong about these guys. 245, 244, 244, let's put that one here. 244, 244, and the other 245 up here. Beautiful. Oh yeah, we're going to replace this old guy. It's a 4078 8 input NOR, 8 input NOR gate. I have since bought some of these, and we're going to replace it. Hello. Okay. New one, 4078. Come on, get in there. Alright, she in there. We got our 2 traces fixed, remember, that we found broken. And this thing is ready to go. New sockets, new decoder. That's our decoder chip. That's our decoder. That's exactly what it is. Being used as a an address decoder. You know what we're going to do first and foremost? What I want to do is, since we replaced the sockets, I want to put the old OG PAL in. I want to put this guy in and make sure we get the same badness. See, that guy's in. There's the OG guy. Let's back this thing up out of the way a little bit. Okay. Back up. Put this up here. Okay. Let's hook up our control, this and that. Okay, I'm going to turn that off. We're going to plug the power supply in. It's all hooked up. We're good to go. We're going to put this ROM board down in, and we'll watch the TV when I fire it up. Okay, that's in. This is in right. And we are on. And I don't know if you can see the TV screen. Still resetting. So now I'm going to turn it off. Get in your way a little bit. I'm going to take this. We're going to put in the new PAL. The old one is now right here. Garbage. Here's the new one. We'll pop it down in this socket. Very good. And I bent the leg. Let me straighten the leg out. Sorry. Yeah, I bent the hell out of a leg. God damn it. Here we go with these sockets. I just don't like them. All right. Okay. Now the new guy. The new PAL is in. Right there. So I'm going to drop that down in. Move this and fire it up. There it is, guys. Robby Roto. The PAL chip had died, in fact. Now we are back. And I have dumped that file. Now I have that file. So that is excellent. Alright. This is going to wrap up this part of the video. The next part is going to be RAM. We got to address the RAM. Remember, both of our RAM cards are still bad, so I got to take care of that. Plus, I purchased on eBay a RGB interface for the card rack system, so I'm going to implement that into this and get Robby Roto over on the color monitor. So that'll be next video, guys. See ya. Alright guys, welcome back to Robby Roto. We're going to start on the RAM cards. If you remember, this was Space Zap. I put the Space Zap RAM cards in there because they were good. Both of the ones in the Robby Roto cage were bad. So I am going to go through. Here's my extender, by the way. I purchased this card rack extender for the RAM, and I also got one for the big cards. So I'm going to put that guy in the cage, and then we'll plug one of the bad RAM cards into it. And what I'm going to do is I'm going to poke with the scope there. I want to look at all of the the data out pins, and I want to look at the data coming out of each RAM. And I have experienced in the past with these 4116s, a lot of times when they go bad, they will flat out float the output, or it'll be pegged low usually it's -5 that blows out, or sometimes -5 will short to ground, and that'll mess the whole system up. But I've seen them either pegged low or floating, so that's what I'm going to look for. So we'll go ahead and set this thing down, and we'll be able to do these, check these RAM chips. So let's get set up and get that ready. Alright, and check that out, guys. I got the extender in the RAM card. This is one of the Space Zap ones. This is one of the good ones. What? What is it? What? What is it? Yeah, so you see there, it's on, and there's your screen working good. So I put this little foam piece behind it to kind of level it, give it a little support, and I'll turn the scope on, and we'll just probe all of the output pins on this. I'll plug in a bad one, and we'll probe the output pins, and that's how we'll go about it. Okay, I put one of the bad RAM cards in, and you can see it's bad, but it's not terrible. But it is bad. It's this guy right here, so we'll go ahead and just probe all these output bits. And I'm gonna focus my camera in on the scope for you. So that you can kind of see that. So let me go ahead and get this set up. I'll be right back. Okay. Pin 14 on these guys is data output. Pin 14, data out. That looks good. There's a bad RAM. I'm going to get my red paint mark paint marker. I gotta start marking these guys up. Red dots for bad RAM. You're just looking for a nice TTL signal here. And this guy is dead. Wait a minute. Whoa, whoa. Hold on. Waiting to see if it ever goes high through one of these cycles, and it doesn't. This thing is dead. Okay, there's one we're going to replace. That looks great. That's what they should look like right there. That looks good. Good. Well, this one's floaty most of the time, and I don't think these are supposed to be floaty at all. I don't like the way this one looks, so we're going to replace this guy too. I know it shoots high every now and again, but I really don't think this thing's any good. And these things, let me look at the pinout again. Read right. Okay. It's got RAS and CAS, which are row strobe and column strobe. It does not have a chip select, so to speak. That's what the RAS and CAS signals do. This should not float, ever. This guy is getting replaced as well. That one was kind of half-ass working a little bit. Here's another one, looks good. Looking good. Looking good. Looking good. Looking good. 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 Looking good. So that one looks like it's got two bad RAMs. And what I'm going to do is I'm going to just jump 2 RAM chips over those. I got me 2 4116s, and I'm going to jump them right over. I'm going to try to jump them over these 2 bad guys and see if it will clear the screen up. This is not foolproof. This, you know, this may not always work. And no, it's not really making a change. But there's the one that I jumped. You can see it kind of going high. See that high spike? That's one of them that I jumped. And here's the other one that I jumped. So that totally fixed this guy. Now I'll take this guy off. Now see it? I'll jump it back over it. See it? There it is. Yeah, so that's definitely a bad chip. As is this one, because you can see when you jump it over it, it really fights it, and you can see those little spikes. So that's 2 rams that we are going to replace on this guy. And I'll back the camera up. And I'll show you which 2 it is. Here's the 2 rams that I jumped over it. It's this guy right here with the red dot and that guy right there. Those 2 do not look good. That's the thing about these rams when they go bad. It's not exactly hard to find them because the outputs go jacked up. It's either these things will short internally and they'll short a voltage straight to ground. Like these things, I've seen them short the -5 right to ground. But that's worst case scenario. So I've got these 2 guys. Let's go ahead and replace these guys and then put this back together and see if our lines clear up. Let's do it. Okie dokie. A little desoldering. This guy here. Second one. Boy, these pads are super weak. Didn't want to come out too good. Boy, these are flaky. Backside pads are super flaky. Well, these are no fun at all. This just absolutely flaky pads. Ridiculous. Couple sockets. Turn the soldering iron, gotta plug the soldering iron in. I have got to clean, I gotta clean that. Okay, there's one socket. Well, it isn't exactly pretty, but it'll be effective. Okay. There's two sockets. So let's go ahead and back this all up. Come back up here. Let me back you up a little bit. Now let's these two rams, I'm going to set them right up. Just dropped one of them. Right there. These are our known good guys. One of them here. One of them here. Okay. Plug this in. Okay. Kind of do the same thing. Let's just lean it down. Okay. Plug this RAM back in, this card. Put my little support under it. And let's see what we get. Fire it up. Still looking good. It's better, but it's still got a bad guy on it. Better, but it's still not right. There's our new RAM. Here's another new RAM. Uh-oh. I may have killed that ram when let me turn it off and remove this guy, because this one was looking pretty flatline. Let me grab another one. Yep. Jumping them might not be a good idea to be jumping these rams. Okay, fired up. And it's still shitty. This one just is like this for some reason. Uh-oh. I don't like this one. Yeah, this ram has a weird looking signal. Starting to wonder if this is actually a RAM problem. Why would this RAM have no output even in test? Okay, this is going to require a little more. This doesn't seem right. This was definitely a bad RAM. That one was definitely bad. Heck, I don't know. I kind of think it might be. You know what, that might need to be. Let's see something. And I can't find. I gotta find some alligator clips. I will be back. Okay, guys, there's another floating chip right here. This one floats. The one that I replaced is still floaty. And this one floats. The one that floats that I didn't replace, if I jump a chip over it, the board really kind of starts to clear up, I think. I don't know if you can see it, but it kind of, see that? And now it's not floaty anymore, it's actually just high now. Now it's back to floaty. Yeah, that's a floater too. I'm going to replace this other floater. I didn't catch that. There's another floaty chip I'm going to replace too. So let's turn this thing down. Remove this. Kind of set this up. Unplug this. Unplug this. Stop that. Move this up out of the way. That other floaty guy is right next door. So I'm going to go ahead and replace the other floaty guy, and then I'll be back. Okay guys, I took a break from the other RAM card. I popped the other, the second RAM card, the second bad RAM card. I popped it in there. And this one right here was the only one that looked funky. It was just a high all the time output. So I'm going to go ahead and replace this guy on this card and see where that gets us. So, and I've kind of figured that you can't really go too crazy with these cards. The top left hand corner here. What is it? Plug that guy back in again. Get a little workout. And while this one is getting ready to go, I kind of want to check my work on this one, because those two outputs float and they should not float. So I want to look at this one about what's going on here. Something's fishy about this. I gotta move this. Oh, there you go. Goodness gracious. That is the pin 15 is the row strobe, I believe. Photos. No, it's the column strobe. Pin 15 is the column strobe, and that there's no continuity. Nope. Nope. Darn it. You can go the leg right down to the bottom of the pad on these. Okay. There's another one. Nope, that's okay. That's definitely a bad trace right there. Pin 15 of that guy. You know, so I got to repair my bad work on that one. I have since figured out the best way to do this, to desolder these, where you're not destroying stuff. Irritating. You have to be really careful with these RAM cards because they're flaky. First off, I need the Coke bottle glasses so that I can see. Flip it over and do the same thing to this side. You just set the iron on the pad and do your thing, and then I just kind of bend the leg over. that should do it for that guy. Should come out nice and clean. Just like that. And that worked out beautiful on that one. Absolutely no damage. I totally screwed the pooch on that other one. What are you doing, bro? Nope. Put this up. Put this up. Plug in the cage. Plug in the power supply. Flip her over. Okay. Put down our little support. Plug in the RAM card. Okay. RAM card. Oh, I need a RAM. Let's unplug the RAM card. Grab a RAM. What is it? What is it? Yeah. What are you doing? Yeah, what are you doing? Okay. Put this RAM in there. Alright, the RAM card is in, so let's fire it up. The RAM passes, but it's obviously not good, right? You got a little flakiness going on here. I put it in test, and it doesn't say RAM's bad, even though it's flaky screen. Nah, now it's saying bad. You know, I really wish this RAM test would tell you what's bad, instead of just saying bad. See? It just says bad. Hey man, you got bad RAM. No kidding. Hey, it's bad. Got bad RAM, man. I'm gonna probe around again. Take a look. Well, that RAM looks good anyway. This is the only one doing that. That one's kind of doing it. Huh. I don't know. They all look decent to me. Uh-oh. I'm going to restart because I shorted something and messed something up. And now see, it does not give me a bad RAM. This is just a flaky RAM. Yeah, I don't know, guys. I really don't know. I wonder if I were to put the test ROM, the Gorf test ROM, I'm just going to try jumping some. I mean, that one that I replaced was definitely bad. That RAM was bad. But that was the only one that really, you could really tell was bad, because it wasn't doing anything. Now we got flaky RAM. There's a flaky RAM on there. And that's just, I can't really probe and find that. Irritating. So I'm going to try jumping around RAMs. I'm going to try jumping RAMs and see if anything clears up. No, no real changes. And this sucks. It's like I'm just going to have to replace RAM. I mean, I don't see any other way of doing this. I mean, I can... Okay, well, let me shut this down. I'm going to try just fixing that trace on that other card that I messed up and see what I get. I'll be right back. Well, guys, I've been busy. As you can see, they're all socketed. I removed every one of them. And I tested every one of them in the Inquisitor. And it's working. There were 5 bad rams. There's 6 bad rams here. But there were actually 5 in this board because I've already replaced 1 in this guy right there. So I've replaced 6 here. 5 of them were bad in this guy. 5 out of 16. It was just a process of I would remove about 3 of them and then I'd test them. Remove 3 more, test 3 more. It turns out 5 of them were no good. So I've got 1 of the cards done. 1 more to go. And I'll tackle that one tomorrow. That's going to be it for tonight. So yeah, 1 card down. Hopefully this one is not as bad. And the one that I did replace in here, this one that I replaced was bad. It's one of those bad ones. But unfortunately, these are just flaky. They look good, but they're not. You know, you can't really tell by just looking at the, just looking at the signal. So they actually have to be tested in the old Inquisitor. So yeah. All right. Well, we'll see you tomorrow with this guy. 1 more. Alright guys, now that we got that done, we got the 1 done, I'm going to start working on this other one, which I've already replaced. Remember, I had the 1 chip here that we knew was bad. So I'm going to go through, and since probing these didn't really tell me anything, I'm just going to go through and start replacing. I'm going to start pulling, socketing, and replacing. So I'll start with this top 4 row. I'll replace all of those guys, see if I get a change there. Then first thing I'm going to do is I'm going to plug this in and get a baseline because I don't remember what it looked like. So let's hook this thing all up. I got my desoldering gun heating up right now. We'll plug this guy in and see what it looks like. So let's go ahead and do that. Okay, so we're hooked back up. This is the board in question. And this is what we're looking like. RAM problem. So like I said, I'll go through, and I've got the repaired card in here, RAM card in there, so that one's good to go. I'm going to start with this row. I'm just going to remove 4, put in sockets, put in new chips, and see if it fixes it. And then if it does, then I'll whittle down which chip is the bad chip. 4 RAMs at a time. It's just the easiest way for me to do it, really. So let's get to it. Start desoldering some RAM chips. Okey-doke. Four at a time. And these rams have not been overheated, so if they are good, then they are good. Okay. Little inspection. Everything looks great. No problem. I found out that the secret to desoldering the chips out of these guys is to use low heat. Turn it down. So let me grab 4 sockets. Let's get the soldering iron warmed up. I guess I'll just turn that off. Okay. Now let's get in on here. I have to have an angle. I have to have a bit of an angle. So we'll try that. Beautiful. Beautiful. Okay, I'm gonna back up and hook the board set back up, and we'll see what we get. Put some new RAMs in there and see what we get. But before we do, I forgot. Let's use the old Inquisitor and see what it tells us. Alright, here we go. That one says it's good. Okay, we got another one that says it's good. Alright, moving on. Alright, those four that I removed, the Inquisitor says are okay. So what I'm going to do is I'm going to just move on and desolder four more. So I'm going to do that off camera, and then we'll come back for some more Inquisitor testing. Well guys, as you can see, I have been busy. I went ahead and I removed all of them and tested all of the RAM in my Inquisitor, and these guys came good. These guys were good. And we had one more bad RAM from the Inquisitor. This guy was bad, and the rest of them were good. So it looks like this card had a total of 2 bad RAMs. So I'm going to repopulate this thing, and we'll plug it in and see what we get. Okay, we are back together, repopulated. And I got all the RAM that I pulled back in, except for the bad one, and the one replacing the bad one is right here. So I got 2 new ones, new old stock or whatever, in here and here. Those are the 2 new ones, and then the rest of them are original. So we are hooked up. And let's go ahead and fire it up and see what we get. And it still looks like crap. Okay, still looks like garbage. It's still doing the same thing. So I believe that's going to be the limitations of, either that's going to be the limitations of the Inquisitor, is it'll just tell you if a RAM is totally blown out. But it will not tell you if under running, working conditions, if it's going to be flaky. That's what's looking like. What is going on here is there's some just flaky. So I think what I'm going to do is I'm just going to replace all of these RAM with 4116s that I have and see how that looks. Now if it does the same thing, then it's probably control logic. But or the shifter's out. There's 166 shifters that shift all the data out. But I'll take a look at I'm just going to pop all new 4116s in here and see what happens. Okay, so this was the one I was just looking at. And you recall it was looking flaky, even still. and I put a new set of RAM in it, a different set of 4116s, and it looked exactly the same. So what I started to do is I started jumping the control, the 166 shifters that shift the 8 data bits out, and these 253s that do the addressing. And I jumped those and I got no change. I got down to here, I just jumped over, and I got a difference with this 14 here. It's a LS 14, and I saw an improvement, but it was still kind of jacked up, but it was still an improvement. So I'm going to go ahead and replace this 14, and I'm going to replace it on both of these guys because I saw the same kind of artifacting with this guy. Not to that degree though, but I'm just for safety's sake, I'm going to replace both of these 14s in these boards, in these RAM boards, and then see where we're at. I believe these are going to be good after that. So let's do that and come back with a couple new LS 14s in these boards. Alright guys, I still am getting RAM problems with this thing, and these are old used RAM that I just had. They test good in the Inquisitor, but I'm going to try something. Since I've got these all socketed, I replaced the 14, no difference. I cleaned the edges up, no difference. I am going to convert this board to 4164s, and I'll go over how that's done. It's really quite simple. You have, you have right here, you have -5, 12, 5. That's the inputs right there. So all you got to do is take your Dremel and cut that, and then cut the 12 right here, and then jump these two spots together. That's all you need to do, and then it's 4164 board. So let's go ahead and do that. I'll set the camera up and we'll go ahead and do that. Alright. Got this Dremel on low speed. We'll just get this done. That's the -5. This is the 12 volt. Alright. Yeah, I got to thinking there, wow, that was kind of dumb. I should have cut this. I should have cut this right here and then jumped this. Now I'm going to have to jump up here at these caps, which is no big deal. But I could have, if I would have cut this right here, I could have just jumped these two together. Well, that'll work. I'll jump them together right here. And that's 5 volts to 12. Alright. I'll be right back. Okay, so that is done, and I'll show you the, that's where you jump 5 and 12 volts, just on those two caps. Alright, and we'll take a quick beep test, and -5 should now be floating. here's the pin for neg 5, and here's for neg 5, and it is floating. You see, neg 5 is floating. 12 volts should be floating, and 12 is right here, and it's floating. But 5 volts should be there. So 5 volts is now on 12 and 5. Ground is still ground. And neg 5 is floating. Now you can safely populate this with 4164 RAM. And let's do that. Be right back. Alright guys, I have been absolutely pulling my hair out over this board right here. No matter what I did, it's still bad, but this is an improvement, believe it or not. I'm absolutely ecstatic to see this screen. This thing. Let me turn it off and let me remove this board. Everything I've thrown at this thing has failed, has not worked. I replaced I've socketed everything you can see. I have an F08 here that I pulled out of another working board and put in here because I was like, maybe, because this didn't have an F, I don't have another F08. So I was like, maybe it's a speed thing. I at this point, I don't know. So I removed one from another board, put it in here. Same thing, and what it was this thing was in the sprite slot. There's basically 2 slots in here for RAM cards, right? One slot will do the RAM for the sprites, sprite RAM. And then the other card is like the screen RAM for the whole background and text and everything, and the whole screen. And then this one, I had this one working just the sprites, and my sprites were sparkly, just completely sparkly. No matter what I did, I replaced all these pull-ups. I replaced all of the pull-up resistors. I replaced the 4 resistors where the data goes in to these guys. There's 4 data resistors. You know, data comes in off of here and goes through resistors and then goes to the data input pin on all of these guys. I replaced those. I've replaced all of this. I've replaced this stuff twice. And what I actually replaced these 2. I originally had these 2. I soldered them into the board, and it didn't work. So I was like, well, I don't know. Maybe I put bad parts in it. I don't know at this point. So I removed them and socketed them. No change. I put different 253s in. No change. So I put the originals back in that I had put in. These guys, the 166s, I had replaced those as well with brand new Texas Instruments LS 166s. Soldered them into the board, and then I had converted this guy over to 164 RAM, if you remember, and all I got were sparkly sprites. And I went as far as to reconvert this back to 4116s, 4027s, whatever. Put the 4027s back in it, put two new caps in there, redid everything, still sparkly. That's when I did the resistors, put it back in, still sparkly. So then I was like, well, I mean, it's highly unlikely, but I'll remove these guys and socket these 166s that I'd already replaced. I removed them, put sockets in. I put those 166s in my tester, and they tested good. But I could put a couple more 166s in, and that's where I'm at now. The sparkly is gone. There's no more sparkly. But there's a RAM error. I think there's just a bad RAM on this card now, which is like, you know, hallelujah, for crying out loud. Let's turn this on, turn it back on, and I'll show you. See, there's no more sparklies in the Robby Roto guy. He's not sparkly anymore. The whole sprites were sparkly before. And but now it's just got a bad RAM. You can see there's lines in there. You know, you can see when he walks, he's walking through black lines, invisible black lines. So that tells me there's just a bad RAM on the card on the card now. So that's where I'm at. So I'm going to lay this thing back down, and I'm going to probe the output pin, see if there's an obvious bad RAM on there, and hopefully you can find this thing like that. So let's do that. Okay, I'll go ahead and probe around on this thing, probe the output bits. See if any of them look nasty. Oh, let's turn it on. Hopefully we get an obvious nasty looking bit. Whoops. That's the worst looking one. I keep shortening because I don't have enough. I'd say this is the worst looking one, but it doesn't exactly look bad. So it's not going to be easy. If I'm going to change any, it's going to be that guy. So let me change that guy. Let me replace that guy really quick. And still bad. And I shorted it again. This bit looks way better than the other one though, so I'm going to throw that in the garbage. So weird, you know. Just this RAM card is a total pain in the ass. I just don't understand. me I'm going to replace 2 rams at a time. See, just kind of see if I get any kind of difference. Okay. It's still bad. Alright, I'm going to just do a process of elimination here. And what I'm going to do is go through and just keep replacing rams until I find out what the bad ram is. I'll be back. Well, holy Toledo, guys. I went back to the original 4027s that I had taken out of the board. I think this one of them had 2 bad chips and the other one had 5. I think this is the one that had 2. So I went back with the original 18 4027s and put 2 good ones in there, and now we pass test. So let's put it out of test. And I'm going to restart it. And there it is, looking perfect. Holy crap, what a pain in the butt. Based on this test, I'm going to say, because I had converted this over to 4164 and it didn't work right. Maybe it won't work in this system. Maybe this system has to be what was originally in here. I went back to the 4027s and it works. 4027 and 4164 maybe are just not compatible. They're not the same. I don't know, because I have done this with Berserk. With a Berserk board, I did convert that RAM board to 4164s and it worked just fine. This one doesn't, though. This is a finicky system. And this was a total pain in the ass. But right now it is running. No, I have one of the Space Zap RAM cards in here. I'm going to cut away. I'm going to put this together as Robby Roto with the 2 RAM cards that have all basically been rebuilt. And we should be good to go. So I'll be right back. All right. And here is the completed Robby Roto board set. Completed. Both of these cards in here are the cards that I rebuilt. You can see they're socketed in there. So those are the 2 Robby Roto cards. Finally. Finally, and it's looking perfect. Here's the Space Zap boards right there. Good working set of Space Zap boards. There's the dead, remember the dead motherboard thing. Yep, here we go. Space Zap, or Robby Roto, finally done. So I am going to hook up, I'm going to hook up, you know what I need to do? I have right here in my Midway card rack stuff, I bought the RGB interface. You know what? That's what I'm going to do. I'm going to wire in the RGB interface so that I can play Robby Roto in color. That'll be another video. As for this, I'm going to call this one good. Finally. I've got to move on from Robby Roto. I actually have another Robby Roto board set on the way too. But I learned a lot from this one that'll make the other one easier. I learned that these RAM cards are super finicky, is what I learned. Whatever they're engineered for, leave that type of RAM in it. Don't try swapping different types of RAMs in these things. You know, if it's got 4116s in it, I'm going to stick with 4116s. If it's got 4027s, I'm sticking with 4027s. So, alright guys. See you on the next one, and be looking out for that color interface, because I do want to play Robby Roto in color. That'll be the last part of this series. How's that? So look out for part, I don't even know what at this point, 10? 9, 10? Be color interface for this guy. Alright, see you then guys. Okay, so getting the Robby Roto set onto the color monitor, I mounted this guy right here. You see the little interface PCB. I screwed it onto the wall right there, and I made two little adapters. This one right here I made, and this goes, that's the output of this guy, and then my red, white, and my red, green, blue ground and sync from there plug into this guy right here, and then go to the monitor. And following the pinout, I had to add this guy right here. This connector right here goes right here on the RGB board, and it just goes into right here, the J3. And what I did, because the video signal goes to this guy, but the video signal can also just go straight to a black and white monitor, which is what I've been doing. So what I did was I didn't eliminate the black and white option. I crimped these two together. One of them goes to the interface board if I'm going to use it for color, and the other just goes to my black and white thing here, off of here, so that I can still use a black and white monitor if I want. Now I have either option. With Robby Roto, the thing is you have to do this. Like when I do Gorf, I'll have to make another one of these. If I get a Wizard of War, I'll have to make another one of these off of the, these are not, this is not universal. This is Robby Roto only. Yeah, so they are different pinouts. It's not a universal setup, so, which is kind of a bummer. It'd be nice if it was, but it's not. So this one is Robby Roto only. So I've got everything all I've got my harness all done, so now I'm going to go ahead and hook Robby Roto up to the color monitor and see how it works. Okay, I got the camera fixed there, so we're going to start setting this stuff up. Here's my power plug. That's all good to go. I can actually go ahead and just get that ready. Plugs into my setup. This has all my controls on it for my Atari joystick. And I will hook the sound up too. Let me grab the my sound amplifier. We're going to hook that all up too. I only can do one channel at a time. One sound channel at a time. Okay. Get the spaghetti wire out. I swear. Okay, this goes to the speakers like so. Okay. And this is just a old computer speaker amplifier, sound amplifier is all it is. Okay. This is going to plug into, we'll do channel 1 first, I guess. Okay, we are plugged up to channel 1. We got to plug all this junk in. This is J2 and J3. Okay. This is J1. Okay. Now we're going to do, I got to plug this guy in to this. Okay. We'll plug this video cable into this. Like that. Right? Yep. That's that. This has to plug into this, the output. Sync. Okay. We're using the color monitor, so I gotta plug it in. Oh, goodness gracious. I think we're all hooked up. Well, I'm pretty confident in my hookup and my following the directions of the pinout and everything. That's proper. That's plugged in. This is not shifted at all. It's in there good. In the right spot. That's right. That is right. I think we're good to go. Let's fire it up. It is working. It's a little shaky. I think I'll just have to mess with the sync a little bit. Maybe. Let me mess around with this connections a little bit. I'll be right back. Guys, it did not want to sync to my Nintendo monitor at all. So, I hooked up a G07 that I have. Look how freaking cool that looks. It works. Alright, I'm going to set this thing up and we're going to play some Robby Roto. Color Robby Roto. Okay, we are set up. We'll turn down some lights. How cool is this, guys? Just remember, not all of the sounds are going to be here. I know that both of the channels work, but I'm just putting it on the other channel, the channel with the walking music. It's got a little more noise, so maybe after I die, maybe we'll play one game this way with this channel, and then I'll switch it to the other channel and play another game, so you can see what sounds are produced by both channels. So let's get into it. Here we go. Darn it! Whoa! Oh, come on. Oh, game over. Okay, so I will change the channel. We'll listen to the other channel. Okay, we'll start up. Here comes the coin. And here we go. I like this game. this game. This game's pretty cool. I like it. I went right through that spider. Darn it. Hey, all right. This game is hard. I'll give it that. It's a tough game. Darn it. And that's the game. Game over. Robby Roto repair is absolutely complete. All right. All righty. Look at that. Boy, this one gave me some problems, didn't it? The only thing that was good on this... Did we have a problem with this CPU board? I don't remember. But the game board was no problem. The pattern board was no problem. The ROM board, the memory board, was a disaster. And these RAM boards sucked. They were hard to get right. So finicky. But, as usual, we prevailed, guys. And look at that. To the persistent go the spoils. Robby Roto, how cool. That's going to wrap up the Robby Roto series. You know, guys, I got another Robby Roto board set coming. Can you believe that? I got another one coming, and it looks like the memory board is battery damaged like this one. So, should be fun. Alright guys, see you on the next repair. And the voting was done on the, I put up a poll for voting. And I am now going to begin the Space Race PCB by Syzygy. Very early Atari. I think it's like 1973 or something like that. So that's the next repair. I'm going to get started on that one today. Pack the Robby Roto stuff up and try to get it on out of here, along with Space Zap. And yeah, so excellent. Peace out, guys. Take it easy and see you on the next repair.